Imagine our planet Earth spinning in silence, its blue-white marble suspended against the black canvas of space. But in this vision, there are no astronauts to photograph it from above, no mission control centers tracking its rotation, no children gazing up in wonder at its place in the cosmos. What would Earth be without us? The sunrise still breaks over the eastern horizon, painting the sky in magnificent hues of gold, amber, and rose. Light streams across mountain ranges, illuminating peaks dusted with snow and valleys shrouded in morning mist. But no hikers stand atop those summits to catch the first light. No photographers frame the perfect shot of sunbeams filtering through trees. The beauty remains absolute and complete, but experiences a curious transformation beauty without acknowledgement. Clouds still form and dissipate in endless patterns across the sky. They gather moisture over oceans, build into towering thunderheads, and release their rain upon forests and plains. Great storms still spiral across the Atlantic, their perfect hurricane eyes visible from space, if only someone were there to see them. These massive weather systems would continue their cycles of formation, growth, and decay, following the laws of thermodynamics and pressure gradients, with perfect indifference to observation. The Amazon rainforest still breathes, inhaling carbon dioxide and exhaling oxygen in the planet's largest respiratory system. Morning mist rises from its canopy as the sun warms millions of leaves. Raindrops still create that distinctive percussion when they hit the layered vegetation. Water still flows through the mighty Amazon River, carrying sediment from the Andes all the way to the Atlantic Ocean. The river still floods its banks seasonally, depositing nutrients across the floodplain. But no indigenous tribes navigate its waters in dugout canoes. No biologists catalog its species. No environmental activists fight to protect its boundaries. In this humanless Earth, the African savanna still witnesses the great migration of wildebeest and zebra, moving in response to rain patterns and fresh grass. Predators still stalk the herds. Lions still coordinate their hunts in the tall grass. But no safari vehicles track their movements. No wildlife documentaries capture the dramatic tension of the hunt. No David Attenborough narrates the life and death drama unfolding beneath the acacia trees. The processes of life continue unabated. Flowers still bloom. Their complex structures and vibrant colors evolve to attract insects, not human admirers. Their petals unfold, their stamens produce pollen, and their scents waft through the air, advertising to pollinators who still visit in this humanless world. The intricate relationship between flowering plants and their pollinators, developed over millions of years of coevolution, continues without human understanding or appreciation of its elegance. Deep in the oceans, coral reefs still form living architecture of astounding complexity. Polyps still secrete calcium carbonate to build the reef structures. Fish of every imaginable color still dart among the coral heads. The symbiotic relationship between coral and algae still maintains this underwater ecosystem. The Great Barrier Reef still stretches for over 1,400 miles along Australia's coast, a living structure visible from space. Yet in this scenario, never mapped, never named, never threatened by human-caused climate change or ocean acidification. Beneath the waves, whale songs still echo through the deep. Humpbacks still compose their complex melodies that change and evolve each season, transmitted across oceanic distances. But no hydrophones record these songs. No marine biologists analyze their patterns. No composers draw inspiration from their haunting beauty. The whales sing to each other alone, their art unwitnessed except by their own kind. At Antarctica, emperor penguins still huddle against the brutal winter, males balancing eggs on their feet through months of darkness and cold. The aurora australis still dances across the southern sky, shimmering curtains of green and purple light, caused by solar particles colliding with Earth's magnetic field. But no research stations dot the icy continent. No time-lapse cameras capture the light show. The penguins' remarkable adaptation to extreme conditions goes undocumented, their evolutionary story untold. The Grand Canyon still exists, carved by the patient Colorado River over millions of years. Layers of ancient rock still tell the story of Earth's geological past. The rising sun still paints the canyon walls in shifting colors, revealing the strata of sandstone, limestone, and shale. But no one stands at the rim, breathless at the vastness. No geologists read the rock layers like pages in Earth's autobiography. No tourists snap photos to capture a fraction of its grandeur. Volcanoes still build islands in the Pacific. Kilauea still sends rivers of molten rock flowing to the sea, adding new land to Hawaii's shores. Magma still rises from the Earth's mantle, reaching the surface through weak points in the crust. The dramatic meeting of fire and water still creates new landscapes. But no volcanologists monitor the eruptions. No Hawaiian legends explain the fury of Pele, goddess of fire. No evacuations are necessary because no communities exist in the path of destruction. The cycles of ice ages would still come and go, driven by subtle changes in Earth's orbit and axis tilt. Glaciers would still advance and retreat across continents, carving valleys and depositing moraines. The evidence of past climate shifts would still be recorded in ice cores and sediment layers, but no paleoclimatologists would extract these cores. No one would reconstruct past climate conditions or use them to understand Earth's complex climate system. The planet's long climate history would remain written, but unread. Forests still change with the seasons. In autumn, chemical processes still trigger leaves to turn brilliant shades of red, orange, and gold before falling. In spring, buds still unfurl into new green growth. But no poets compose odes to autumn's glory. No families take weekend drives to view the fall colors. No children jump into piles of fallen leaves. The seasons still turn, but their passage goes unmarked by festivals or calendars. The night would bring its own unmarked beauty. Fireflies would still rise from meadow grasses on summer evenings, their synchronous flashing, creating waves of light across fields. The purpose remains the same: to attract mates, but no children would chase them with cupped hands. No scientists would study their bioluminescent chemistry or their communication patterns. What happens to a sunset when no one watches it fade? Does a galaxy still shimmer when no consciousness marvels at its light? The cosmic tapestry that stretches across our night sky, does it matter without eyes to witness its grandeur? We humans have always placed ourselves at the center of existence, believing the universe somehow performs for us alone. But tonight, we explore a humbling truth. The cosmos would continue its magnificent dance, even if we never existed. Stars would still forge elements in their burning hearts. Black holes would still devour light at the centers of galaxies. The moon would still pull at unseen oceans. Tonight, we drift into that silent cosmosa universe, untouched by awareness. Not lifeless, but unseen. This is what the universe would look like without USA reality, where beauty exists without witness, where light travels eternally through emptiness, never to be received by wondering eyes. Meteor showers would still streak across the night sky as Earth passes through comet debris fields. The Perseids, the Leonids, the Geminids would all arrive in their seasons, but with no names, no anticipation, no upturned faces watching from darkened backyards. The momentary flashes of light would appear and disappear, unobserved, except perhaps by nocturnal animals who might briefly glance skyward at the sudden movement. The world's great migrations would continue. Monarch butterflies would still make their remarkable multi-generational journey from Canada to Mexico. Arctic terns would still fly from pole to pole, following the summer. Salmon would still fight their way upstream to spawn in the rivers of their birth. These feats of navigation, these triumphs of instinct over impossible odds, would occur without human observers marveling at their determination. Natural selection would still shape species, adapting them to their environments through the simple mechanism of differential survival. Evolution would continue its patient work, testing variations against the challenges of existence. New species would emerge, others would disappear. The great branching tree of life, growing and pruning itself according to fitness and chance. But no Darwin would sketch its outline. No taxonomists would catalogue its diversity. No conservation biologists would fight to preserve its endangered branches. The Earth's magnetic field would still protect the planet from solar radiation, occasionally weakening and strengthening, sometimes even reversing its poles. These magnetic shifts would still be recorded in cooling volcanic rocks, the iron particles aligning with the field as the lava solidifies. The record would be there, but no paleomagnetists would read it. The great geological engine would continue running. Plate tectonics would still move continents at the pace of growing fingernails. Mountains would still rise where plates collide. Earthquakes would still release sudden tension along fault lines. The Pacific Ring of Fire would still outline the boundaries where oceanic plates subduct beneath continental ones. But these movements would have no names, no monitoring systems, no Richter scale to measure their intensity. In caves, water dripping through limestone would still create spectacular formations, stalactites reaching down from ceilings, stalagmites growing upward from floors, sometimes meeting to form columns after tens of thousands of years. Crystal formations would still develop in geodes and caverns, their geometric patterns following the molecular structure of their minerals. But no spelunkers would explore these underground wonders with headlamps. No tourists would gasp at chambers decorated with nature's patient artistry. Rivers would still carve new paths across landscapes. Erosion would still sculpt rock into arches and hoodoos. Wind would still shape sand dunes into perfect curves. Water and ice would still crack mountains into scree fields. The slow, persistent forces of weathering would continue their work, but no geomorphologists would classify the resulting landforms. No national parks would be established to protect the most spectacular examples. The planet's biodiversity would develop along different lines without human influence. Without deforestation, habitat fragmentation, pollution, or climate change, species would face only their natural predators and competitors. Some might thrive that have struggled under human pressure. Others might decline naturally, outcompeted in evolution's endless refinement. The balance would be different, but a balance would still exist, governed by the checks and balances of ecological relationships, rather than conservation management plans. And what of the places humans have shaped so thoroughly? Cities would gradually be reclaimed by nature. Buildings would crumble as water infiltrates cracks, freezes, and expands. Plants would take root in gutters and sidewalk cracks. Animals would move into abandoned structures. Over decades and centuries, the concrete jungles would return to actual jungles, forests, or grasslands, depending on the local climate. Earth's self-healing processes would slowly erase the evidence of human civilization. The night skies would grow darker without artificial light. Stars that have been invisible to city dwellers for generations would shine brightly again. The Milky Way would stretch in its full glory across the celestial sphere, no longer competing with streetlights and billboards. Light pollution would fade as power plants stopped working, and the thin atmosphere would once again provide the only filter between Earth and the cosmic light show overhead. Without agricultural cultivation, farmlands would revert to their natural state. The carefully bred crops, larger, sweeter, more productive than their wild ancestors, would face natural selection without human protection. Some might persist in altered form. Others would be outcompeted by hardier wild relatives. The neat rows of monoculture would give way to diverse ecosystems, appropriate to each region. The earth would not be silent. Birds would still sing their dawn chorus. Wolves would still howl to establish territory. Thunder would still crack across skies. Waves would still crash on shores. Wind would still whistle through canyons and rustle leaves. The soundscape would change without human voices, without engines, without music, but it would remain rich with natural acoustics, perhaps even richer without our constant noise. Without us, Earth would neither mourn nor celebrate. It would simply continue. Its beauty would still exist, absolute and intrinsic, requiring no human appreciation to validate it. The planet would go on turning, seasons changing, life adapting and evolving. Everything that makes Earth remarkable would remain. The only thing missing would be anyone to remark upon it. When darkness falls across a human-free Earth, the greatest show in the universe still unfolds overhead. The night sky reveals itself in stages, first with the brightest stars appearing like scattered diamonds against deepening blue, then with thousands more emerging as true darkness settles. Without city lights to compete with their ancient glow, without light pollution bleeding upward from human habitations, the stars reclaim their dominion over the night. The Milky Way galaxy still arches overhead, that magnificent river of light comprising billions of stars so numerous and distant they blend into a luminous band. Its spiral arms still wrap around a central bulge, where a supermassive black hole quietly consumes matter at the galactic core. The galactic disk still rotates once every 225 million years, carrying our solar system along in its cosmic carousel. But in this human-free universe, no astronomers track this movement. No children learn the galaxy's name. No cultures incorporate this celestial landmark into their mythologies. Patterns still exist in the stars. The configurations we know as Orion, Ursa Major, Cassiopeia, and Scorpius still form their distinctive shapes. But without human imagination to connect these dots into pictures, without stories to explain their arrangements, they remain simply sparse nuclear furnaces, burning at different distances. Their apparent proximity merely a trick of perspective from our particular vantage point in space. The planets still wander through the ecliptic, moving against the fixed background of stars. Venus still shines brilliantly as the morning or evening star. Mars still glows with its distinctive reddish hue. Jupiter still dominates with its massive presence. Saturn's rings still reflect sunlight, though no telescopes capture their ethereal beauty. These wanderers follow their orbits as they have for billions of years, their paths predicted perfectly by the laws of gravitation, but with no astronomers to calculate their positions or civilizations to name them after gods. Meteor showers still occur when Earth passes through debris trails left by comets. The Perseids still peak in August, the Leonids in November, the Geminids in December. Tiny particles of dust and rock still enter the atmosphere at tremendous speeds, heating to incandescence through friction before burning up completely or occasionally surviving to reach the ground as meteorites. But no observers marvel at these shooting stars. No children make wishes upon them. No meteor astronomers count their frequency or map their radiance. Comets still make their long journeys from the Oort cloud at the solar system's edge, swinging around the Sunday before returning to the cold outer darkness. Their icy nuclei still warm as they approach the Sunday, releasing gases that form the distinctive tails that always point away from our star, pushed by the solar wind. These celestial visitors still arrive unexpectedly, grow brighter, then fade away, but no comet hunters scan the skies to discover them. No names like Halley, Hale-Bopp, or McNaught become attached to these travelers. Their visits go unheralded and unrecorded. Auroras still dance in polar skies when solar particles interact with Earth's magnetic field. Curtains of green, pink, and purple light still shimmer and wave over the Arctic and Antarctic. The solar wind still carries charged particles from the Sunday, and Earth's magnetosphere still channels them toward the poles, where they excite atmospheric gases to create these luminous displays. But no indigenous peoples interpret these lights as spirits or ancestors. No tourists travel to northern latitudes, hoping to witness the spectacle. The skies perform their light show for an audience of none. Solar eclipses still occur when the moon passes directly between Earth and Sunday, casting its shadow on our planet's surface. For a few minutes, day still turns to eerie twilight along the narrow path of totality. The sun's corona, normally invisible against the daytime sky, still reveals itself as a pearly halo around the moon's silhouette. Birds still fall silent, confused by the sudden darkness. But no human eyes widen in wonder at this cosmic alignment. No ancient civilizations interpret it as an omen. No modern scientists use it as an opportunity to study the sun's atmosphere. The moon still goes through its phases as it orbits Earth, from new to full and back again. Its cratered face still bears the scars of ancient impacts. It still raises tides in Earth's oceans through gravitational attraction. It still gradually spirals away from Earth at a rate of about 3.8 centimeters per year, its orbit slowly expanding. But no lunar calendars track its cycles. No werewolf legends arise from its full phase. No human footprints mark its dusty surface, and no flags claim territories on behalf of nations that no longer exist. Stars still live out their life cycles, from birth in stellar nurseries, like the Orion Nebula, to eventual death as white dwarfs, neutron stars, or black holes. depending on their mass. Massive stars still explode as supernovae, briefly outshining entire galaxies before fading away, leaving behind exotic remnants and seeding space with heavy elements. These stellar events still occur roughly once per century in our galaxy, but with no astronomers to detect them. These cosmic fireworks flash unobserved. Binary stars still orbit their common center of mass, some so close they transfer material between them, others widely separated. Variable stars still pulse with changing brightness in regular cycles. Red giants still expand as they exhaust their core hydrogen, while white dwarfs cool over billions of years. The full diversity of stellar life cycles continues across the galaxy, each star following its evolutionary path, determined by its initial mass and composition. But no spectroscopes analyze their light. No astrophysicists classify their types. No astronomers catalog their positions. The constellations gradually shift over thousands of years. Due to Earth's axial precession, the slow wobble of our planet's axis that completes one cycle every 26,000 years. The North Celestial Pole, currently marked approximately by Polaris, traces a circle through the sky over millennia. The zodiacal constellations slowly drift with respect to the seasons, but without human timekeeping, without astronomical observations spanning generations, these gradual changes go unnoticed and unmeasured. Galaxies beyond our own still shine in the darkness, though even in the clearest skies, only a few are visible to the naked eye. Andromeda, our nearest major galactic neighbor, still appears as a faint smudge of light 2.5 million light-years distant. The Magellanic Clouds, satellite galaxies of the Milky Way, still hover like luminous clouds visible from the southern hemisphere. But no astronomers aim telescopes to resolve their spiral arms. No cosmologists measure their redshifts to determine their motion relative to us. No scientists map their distribution to understand the large-scale structure of the universe. Light from distant quasars, powered by supermassive black holes in galactic centers, still journeys toward Earth, having departed billions of years ago when the universe was young. This ancient light still carries information about conditions in the early cosmos, but without observers to receive and interpret these signals, the messages go unread. The cosmic history remains untold. The cosmic microwave background radiation, the afterglow of the Big Bang itself, still permeates all of space, providing evidence of the universe's fiery birth 13.8 billion years ago. This omnipresent signal, cooled by expansion to just 2.7 degrees above absolute zero, still contains subtle patterns that reveal the seeds of cosmic structure. But no radio telescopes detect this radiation. No cosmologists analyze its characteristics. No Nobel Prizes reward its discovery. Gravitational waves, ripples in space-time caused by violent cosmic events like colliding black holes, still propagate across the universe at the speed of light. These distortions still briefly alter distances between objects by tiny fractions, evidence of Einstein's prediction that gravity represents curvature in the fabric of space-time itself. But no LIGO-like detectors register these minute fluctuations. No teams of scientists announce new confirmations of relativity theory. Dark matter still forms the invisible scaffolding that holds galaxies together, its gravity preventing stars from flying apart despite their rapid rotation. Dark energy still drives the accelerating expansion of the universe, pushing galaxies ever farther apart at an increasing rate. These mysterious components, together comprising 95% of the cosmos, still dominate cosmic evolution, but with no physicists to puzzle over their nature, their mysteries remain not merely unsolved but unposed. The night sky still tells the story of our cosmic origin, every atom in our world forged in stellar furnaces, or during the Big Bang itself, but with no one to decipher this tale. The connection between stardust and earthly matter remains an unrecognized truth. The hydrogen in water, the carbon in organic molecules, the oxygen we breathe, the calcium in bones, the iron in blood all, still trace their ultimate origin to cosmic processes. But the profound link between astronomy and existence goes unrealized. Without human observers, the distinction between astronomy and astrology never emerges. No pseudoscientific claims compete with evidence-based cosmology because neither exists. The planet's positions hold no imagined influence over personalities or destinies, but neither do they reveal the workings of gravitational law or the history of solar system formation. The stars guide no sailors across oceans, inspire no poets to contemplation, prompt no philosophers to question our cosmic significance. The universe still unfolds according to physical laws. Gravity still draws matter together, while dark energy pushes space apart. Electromagnetic radiation still carries energy across vast distances. Strong and weak nuclear forces still bind particles within atomic nuclei. Quantum effects still govern the behavior of the very small. The fundamental constants, the speed of light, Planck's constant, the gravitational constant, remain unchanged. But no scientists measure these values. No theorists seek a grand unified theory to explain them. No mathematicians express their relationships in elegant equations. The universe remains indifferent to observation. Stars do not shine to be seen. Galaxies do not spiral to be admired. The cosmos does not arrange itself for appreciation. It simply is a reality defined by physical processes, rather than perception, by matter and energy, rather than meaning. Without human consciousness to project significance onto celestial patterns, the night sky exists purely as itself an unwitnessed spectacle of unimaginable scale and complexity, continuing its slow evolution regardless of acknowledgement. The night sky ignored is still the same night sky full of the same objects following the same physical laws, but it exists in a state we can hardly conceive, pure being without interpretation. No mythologies explain the heavens. No religions find divine signs in celestial arrangements. No sciences extract knowledge from starlight. The universe remains uninterpreted, unexplained, unauthorized, true to itself alone, a reality complete without perception. In our world, the moon has been humanity's constant celestial companion, inspiring myths, marking time, guiding travelers, and eventually becoming our first destination beyond Earth. But in a universe without us, our nearest neighbor continues its patient orbit in perfect silence, with no one to tell its stories or hear its quiet testimony. The moon still rises and sets across Earth's skies. Its silvery light still casts shadows across landscapes, and its gravitational pull still raises tides in Earth's oceans. Its familiar face, formed by ancient lava flows, creating darker regions we call Maria, or seas, still gazes down upon Earth. The patterns we know as the man in the moon, or the rabbit in Asian traditions, still exist in those volcanic plains and highland regions, but without human pareidolia to detect faces and figures in random patterns, they remain simply geological features, without meaning or mythology. No ancient cultures watch its phases to create lunar calendars. No farmers plant by its light or harvest under its full face. No lovers stroll beneath its romantic glow. No werewolf legends emerge from its influence. No children's stories feature the moon as a character. No languages develop words to distinguish between its waxing and waning forms. The cycles continue, but they mark nothing in human experience, they simply are. The moon still bears the scars of its violent history. Impact craters of all sizes still pockmark its surface, from tiny pits to massive basins like Imbrium and Orientale. Each depression still tells the story of a cosmic collision. Some recent by geological standards, others dating back to the early heavy bombardment period, over 4 billion years ago when the solar system was young and chaotic. But no scientists date these impacts. No geologists classify their morphology. No astronomers name them after famous intellectuals throughout history. Its surface still holds the keys to understanding the early solar system, a preserved record, largely erased on Earth by weathering, erosion, and plate tectonics. The moon still keeps its ancient face largely unchanged over millions of years, a time capsule of cosmic history. But no lunar geologists examine samples under microscopes. No dating techniques determine the age of its rocks. No theories of its formation test the giant impact hypothesis against chemical evidence. The Moon still experiences extreme temperature swings as it rotates. During the 2-week lunar day, temperatures still climb to 127 degrees Celsius in direct sunlight. During the equally long lunar night, they still plummet to negative 173 degrees Celsius. Without an atmosphere to regulate heat, these dramatic shifts continue to stress lunar rocks, causing them to break down over time in a waterless, windless form of erosion. But no environmental scientists monitor these conditions. No engineers design habitats to protect against these extremes. Micrometeorites still constantly bombard the lunar surface, gradually turning the uppermost layer into a fine powder, the lunar regolith, or soil, that covers most of the surface. This grayish dust, sharp and abrasive because it has never been weathered by water or wind, still maintains its jagged edges. But no astronauts trudge through it, leaving footprints that would otherwise remain undisturbed for millions of years in the airless environment. The Moon still protects Earth in subtle ways. Its gravity still captures some incoming asteroids and comets that might otherwise strike our planet. Its stabilizing influence on Earth's axial tilt still helps maintain our relatively stable climate over long periods. These protective functions continue whether acknowledged or not, the Moon serving as Earth's silent guardian, without recognition or gratitude. Moonquakes still occur, some caused by gravitational interactions with Earth, others by thermal expansion as the lunar day dawns, still others by meteorite impacts or internal adjustments in the Moon's gradually cooling interior. These seismic events still send vibrations ringing through the Moon like a bell, but no seismometers record their strength or location. No geophysicists use them to map the lunar interior structure. The Moon still gradually spirals away from Earth at about 3.8 centimeters per year, its orbit slowly expanding due to the transfer of Earth's rotational energy through tidal interactions. This imperceptibly slow dance has been ongoing for billions of years and will continue for billions more, eventually resulting in a Moon that appears smaller in Earth's sky, and Earth days that last longer than 24 hours. But no mathematicians calculate this rate. No timekeeping adjustments account for it. No far future calendars plan for its effects. The lunar far side, which never faces Earth due to tidal locking, still remains hidden from Earthbound view. Its heavily cratered surface, with fewer of the dark maria that dominate the near side, still tells the tale of different evolutionary paths for the two hemispheres. But no space probes orbit to map this hidden terrain. No radio telescopes take advantage of its radio-quiet environment shielded from Earth's electromagnetic chatter. The extreme environments at the lunar poles still harbor permanently shadowed craters, where temperatures remain cold enough to trap volatiles like water ice. These potential resources, delivered by comet impacts over billions of years, still accumulate in these cold traps. But no prospectors seek these deposits for future lunar colonies. No scientists analyze their composition for clues about the early solar system's volatile distribution. Solar wind particles still embed themselves in the lunar soil, the Moon having no magnetic field to deflect this constant stream of charged particles from the Sunday. These implanted atoms, including rare isotopes of helium, still accumulate in the regolith, recording the history of solar activity over billions of years. But no miners harvest these potential fusion energy resources. No researchers extract this record of solar evolution. The Moon still experiences a day-night cycle that lasts approximately 29.5 Earth days, the same as its orbital period around our planet. Each location still experiences about 2 weeks of relentless sunlight followed by 2 weeks of frigid darkness. During lunar daylight, the harsh, unfiltered solar radiation still breaks down materials on the surface through a process called space weathering. But no solar arrays capture this abundant energy. No habitats cycle through powering up and hibernating with this long rhythm. In our history, the Moon became a symbol of reaching beyond our earthly cradle, the first place humans set foot on another world. But in this humanless scenario, no Saturn V rockets roar to life carrying Apollo astronauts. No Neil Armstrong makes history with a small step and giant leap. No footprints mark the Sea of Tranquility, No American flag stands rigidly in the airless environment. No laser reflectors enable precise distance measurements. No lunar module descent stages or abandoned equipment litter the surface as monuments to exploration. The plaque that in our timeline reads, "Here men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace, for all mankind never exists." The words, "The eagle has landed," are never spoken. No lunar samples return to Earth laboratories. No geologists debate the moon's origin based on its chemical composition. No children dream of becoming astronauts after watching grainy television images of bouncing moonwalks. The moon's regular phases, new, crescent, quarter, gibbous, full still cycle predictably as its position changes relative to Earth and Sunday. These phases still create different lighting conditions across the lunar surface, shadows lengthening dramatically near the terminator line, where light meets dark. But no photographers capture these dramatic landscapes. No observers note how features appear and disappear with changing illumination. No lunar phase names enter any language. Earth still presents a dramatic sight from the lunar surface, a blue marble hanging in the black sky, 4 times larger in apparent size than the moon appears from Earth, and far more colorful with its swirling white clouds, blue oceans, and green and brown landmasses. The Earth still goes through phases, as seen from the moon, complementary to the lunar phases we see. But no astronauts experience the profound perspective shift of seeing our home planet as a small, fragile oasis in space. No Earthrise photos become iconic images changing humanity's perception of our place in the cosmos. Without humans, the moon maintains its silence, not merely the absence of sound in its vacuum environment, where no molecules can transmit vibrations, but a deeper silence. The absence of human meaning, human stories, human wonder. No children's books feature friendly moon faces. No lovers associate its light with romance. No werewolf legends connect its full phase with transformation. No scientists debate theories of its formation. No engineers design missions to explore its surface. No visionaries plan settlements in its lava tubes. The moon continues its orbit without witness. It experiences eclipse seasons when it passes through Earth's shadow in total lunar eclipses, its surface darkening and often taking on a coppery hue as Earth's atmosphere refracts sunlight around the edges of our planet. It occasionally aligns perfectly to block the Sunday in a solar eclipse, its shadow racing across Earth's surface at over 1,600 kilometers per hour. These celestial alignments, so meaningful in human culture, become merely physical events, the predictable consequences of orbital mechanics, rather than omens or spectacles. The moon still influences Earth in countless ways beyond the obvious tidal effects. Its gravitational pull still slightly distorts Earth's shape. Its presence still helps stabilize Earth's axial tilt, preventing the wild variations that would cause extreme climate shifts. It still occasionally captures passing asteroids, sometimes redirecting them to impact its own surface rather than Earth's. The moon remains Earth's celestial partner in a cosmic dance that has continued for 4.5 billion years, whether observed or not. Perhaps most profoundly, without humans, the moon never becomes a symbol of anything. It never represents distant goals worth reaching, never becomes a metaphor for the seemingly impossible made attainable through human ingenuity and determination. No one ever uses the phrase moonshot to describe ambitious projects. No one ever promises the moon to a loved one. The lunar surface never becomes magnificent desolation, because no one ever stands there to make that observation. In this humanless cosmos, the moon is not romantic or mysterious or challenging or symbolic. It is simply itself a 3,474-kilometer diameter rocky satellite orbiting a larger rocky planet, one of countless moons in one of countless solar systems, in one of countless galaxies. Its beauty is not diminished by the absence of appreciation, but it exists in a state of pure objectivity, uncolored by human perception, untouched by human imagination, unclaimed by human ambition. The moon shines on, reflected sunlight, bouncing off ancient regolith, illuminating Earth's nights as it has for billions of years before humans evolved, and as it will for billions of years after our species' eventual extinction. Its light falls on forests and oceans, mountains and deserts, illuminating a living Earth going about its biological business without human participation. The moon continues its silent witness, itself unwatched, uncelebrated, unnamed yet still fully itself, still complete in its existence, whether acknowledged or not. What is time when no one measures it? How does it flow when no clocks mark its passing? No calendars track its cycles, no historians record its events. In a universe without human consciousness, time continues but transforms into something nearly unrecognizable from our experience. Without human observers, time loses its segmentation. No seconds tick by on wristwatches. No minutes accumulate into hours. No work weeks structure labor and leisure. No weekends provide rhythmic breaks in routine. No months organize payments and plans. No years commemorate birthdays or anniversaries. Time flows as a continuous stream rather than discrete units, unmarked by human-created boundaries. The natural cycles that inspired our time measurements still continue. The Earth still rotates on its axis, creating the alternation of day and night. The Moon still orbits Earth approximately every 29.5 days, cycling through its phases. The Earth still revolves around the Sunday every 365.25 days, creating the progression of seasons in temperate zones. But without human timekeeping, these cycles are merely recurring physical phenomena, not units on a chronological grid. The seasons still change across the planet. Spring still brings new growth in forests and grasslands. Summer still ripens fruits and extends daylight hours in higher latitudes. Autumn still turns leaves to brilliant colors before they fall. Winter still brings snow to mountains and dormancy to many plant species. These changes still drive animal migrations, hibernation patterns, and reproductive cycles. But no harvest festivals mark the abundance of fall. No solstice celebrations acknowledge the turning points of light and darkness. No spring rituals welcome the return of growth. These natural transitions occur without ceremony or recognition. Geological time flows at its characteristic glacial pace. Tectonic plates still drift at rates measured in centimeters per year, continuing the slow dance that began billions of years ago when Earth's crust first solidified. Continental masses still collide in extremely slow motion, pushing up mountain ranges over millions of years. Erosion still gradually wears these peaks down, carrying sediments to lowlands and oceans. Rivers still cut through landscapes, deepening their valleys grain by grain. But without geologists to measure these processes, without dating techniques to establish timelines, without theories of continental drift to explain the patterns, these changes simply occur without interpretation or contextualization. Rock layers still accumulate in sedimentary basins, creating the stratigraphic record that in our world provides the timeline of Earth's history. Fossils still form when organisms are buried quickly in conditions that prevent complete decomposition, allowing minerals to replace organic materials or create detailed impressions. These physical artifacts still chronicle the evolution of life on Earth. But without paleontologists to excavate and study them, without museums to display them, without evolutionary theory to explain their progression, this record remains buried and unread a book with no reader. Ice ages still come and go, driven by cyclical variations in Earth's orbit and axial tilt, the Milankovitch cycles that create regular patterns of cooling and warming over tens of thousands of years. Glaciers still advance and retreat across northern continents, scraping and sculpting landscapes, transporting enormous boulders far from their sources, creating moraines, eskers, drumlins, and other distinctive geological features. The evidence of these cycles still accumulates in ice cores, sediment layers, and rock formations. But without glaciologists to extract this record, without climatologists to interpret it, the story of Earth's climate history remains untold. Trees still add growth rings each year, wider in favorable conditions and narrower in times of stress. These rings still create a chronological record of local climate conditions, responding to rainfall, temperature, and other environmental factors. But without dendrochronologists to count and measure these rings, without cross-dating techniques to establish precise timelines, Without the science of dendroclimatology to reconstruct past conditions, this natural calendar remains unexamined. Radioactive elements still decay at their characteristic rates. Carbon -14 still transitions to nitrogen. -14 with a half-life of approximately 5,730 years. Potassium -40 still decays to argon -40 with a half-life of 1.25 billion years. Uranium -238 still decays through multiple steps to lead -206 with a half-life of 4.5 billion years. These processes still provide natural clocks embedded in Earth materials, but without radiometric dating techniques, without scientists to analyze isotope ratios, without laboratories to measure decay products, these temporal markers remain unexploited. Stars still progress through their life cycles, from birth in gas clouds through main sequence burning to various end states depending on their mass. Our Sun still converts hydrogen to helium through nuclear fusion, as it has for about 4.6 billion years, and will continue for another 5 billion years before expanding into a red giant. Across the galaxy, stars still form, shine, and die on timescales ranging from millions to trillions of years. But without astronomers to classify their stages, without astrophysicists to model their evolution, without telescopes to observe different stellar populations, this cosmic chronology remains uncharted. All across the planet, processes continue at widely varying rates. Radioactive decay might transform an atom in a fraction of a second. Continental drift might move a landmass a few centimeters in a year. A redwood tree might live for thousands of years. A mayfly might complete its adult life in a single day. A single-celled organism might divide every 20 minutes. A creosote bush in the Mojave Desert might persist for 12,000 years, gradually expanding outward as a clonal colony. These diverse timeframes continue to operate simultaneously, each appropriate to its scale and context. But without humans to compare them, without the concept of time as an abstract dimension, these rates simply are what they are, neither fast nor slow, just appropriate to their processes. Without human memory, time loses its narrative quality. Events happen, but are not recorded or remembered. No histories link past to present. No predictions connect present to future. No imagined counterfactuals explore what might have been. Without these mental constructs, time collapses into an eternal present, not because the past and future don't exist, but because there is no consciousness to distinguish them through memory and anticipation. The age of the universe, approximately 13.8 billion years since the Big Bang, still represents a physical reality. The cosmic microwave background radiation still preserves evidence of conditions just 380,000 years after the universe's beginning. Light from distant galaxies still carries information from billions of years in the past. These vast timeframes still structure cosmic evolution, but without cosmologists to measure them, without theories to explain them, without the human struggle to comprehend such immensities, these temporal abysses simply exist, neither comprehensible nor incomprehensible. Rhythms still occur at every scale. Ocean waves still rise and fall on beaches. Wind still forms ripples in sand dunes. Hearts still beat in countless animal species. Fireflies still flash in synchronized patterns on summer nights. Cicadas still emerge from underground in 13 or 17-year cycles. Tides still ebb and flow with lunar gravity. Earth's magnetic field still reverses periodically over hundreds of thousands of years. These natural frequencies continue their oscillations, but without music theory to analyze their patterns, without physics to explain their causality, without mathematics to calculate their periods, these rhythms remain unquantified. Without the concept of progress, time loses its directional quality. Evolution still occurs, adapting organisms to their environments through natural selection, but without the narrative of advancement, this process becomes simply change rather than improvement. Technology doesn't develop because it doesn't exist in the first place. Knowledge doesn't accumulate because there are no minds to gather and preserve it. Without these typically human frameworks for understanding temporal change, time becomes cyclical rather than linear, a constant returning rather than a directed journey. Without deadlines, schedules, or appointments, time loses its pressured quality. Nothing is ever late, because no expectations exist. Nothing is ever wasted, because no opportunity costs are calculated. Nothing is ever efficient or inefficient, because no comparative evaluations occur. The tyranny of the clocker, uniquely human invention, never emerges to regulate activities or standardize experiences. Natural processes take exactly as long as they take, neither hurried nor delayed. Without historical records, time loses its retrievable quality. Events that would be momentous in human history, massive volcanic eruptions, extinction events, major climate shifts occur, but leave only physical evidence rather than documented accounts. The eruption of Krakatoa still happens in 1883, ejecting cubic kilometers of material into the atmosphere and affecting global climate. But without observers to record it, without news media to report it, without scientific instruments to measure its effects, this event becomes merely another link in the chain of geological processes that have always shaped Earth. Without anticipation, time loses its anxiety-producing quality. No creature worries about retirement savings or career advancement. No being fears its mortality in an abstract sense, even though all still eventually die. No consciousness projects itself into imagined futures, either fearful or hopeful. The constant now of animal experience, always immediate, always present-focused, becomes the universal mode of temporal existence. Without nostalgia, time loses its emotional resonance. No creature yearns for golden ages past. No being constructs idealized histories. No consciousness compares present circumstances unfavorably with remembered conditions. The psychological habits that make time emotionally significant for humans, the sense of loss for what's gone, the anticipatory dread or hope for what's coming, never develop in a consciousness-free world. Genetic time still flows as DNA transfers from generation to generation, occasionally modified by mutations that may prove beneficial, neutral, or detrimental to survival. Evolution still occurs through natural selection, with more favorable traits becoming more common in populations over time. But without evolutionary theory to explain this process, without paleontology to document it through the fossil record, without genetics to analyze its mechanisms at the molecular level, this biological history remains untheorized. Cosmic time still extends into the far future, where our Sunday will eventually exhaust its hydrogen fuel, expand into a red giant, possibly engulfing Earth's orbit, then collapse into a white dwarf that will slowly cool over trillions of years. The universe still follows its trajectory toward increased entropy, with galaxies moving farther apart due to cosmic expansion, with stars gradually using up available hydrogen, with black holes eventually evaporating through Hawking radiation. But without cosmologists to calculate these timelines, without philosophers to contemplate their meaning, without science fiction writers to imagine their consequences, this cosmic fate remains merely physics rather than destiny. In this timeless timer, in this time without human measurement or mini events, still have causes and effects. Sequences still matter. Earlier states still influence later ones. The laws of thermodynamics still create an arrow of time from past to future. But without the human framework of minutes and millennia, without the human concepts of history and progress, without the human emotions of anticipation and nostalgia, time becomes something almost unimaginable from our perspective. Pure duration without demarcation, pure sequence without segmentation, pure change without narrative. This is time without thought, not absent or frozen, but transformed into its natural state, before human consciousness imposed its frameworks upon it. The universe still ages. Earth still cycles. Life still evolves. But time itself returns to what it was before we named it and claimed to understand it, the mysterious dimension through which all things pass, unmeasured but never paused, unwitnessed but never still. Far beyond our planet, beyond our solar system, beyond even the vast spiral of our home galaxy, the universe continues its grand expansion. In the absence of human observers, hundreds of billions of galaxies each, containing hundreds of billions of stars, move through the cosmic void, following trajectories set by gravity, dark matter, and the mysterious force we call dark energy. These immense structures, these island universes, continue their stately dance whether witnessed or not. Our own Milky Way galaxy still rotates once every 225 million years, its spiral arms winding around a central bulge, where a supermassive black hole, Sagittarius A, star quietly consumes matter at a leisurely pace. The entire galactic disk, spanning about 100,000 light-years, completes this rotation with stars moving at different speeds depending on their distance from the center. The Sunday and its planets travel through space at about 828,000 kilometers per hour relative to the cosmic microwave background. Yet due to the vast distances involved, this tremendous speed appears as nearly motionless over human timescales. The local group or galactic neighborhood continues its complex gravitational interactions. The Milky Way and the Andromeda Galaxy, Messier 31, the two largest members of this group, still move toward each other at approximately 110 kilometers per second. In about 4.5 billion years, they will begin a cosmic collision, their spiral arms stretching and distorting as they pass through each other. Over billions of years, they will merge into a single, larger elliptical galaxy, sometimes called Milkomeda or Andromeda Way by astronomers in our human timeline. But in this humanless universe, this future merger will have no name, no witnesses, no scientific papers analyzing its dynamics. The large and small Magellanic Clouds, satellite galaxies of the Milky Way visible from Earth's southern hemisphere, continue their orbital dance around our galaxy. These irregular dwarfs, connected by a stream of hydrogen gas called the Magellanic Stream, are being gradually disrupted by the Milky Way's gravitational field. Stars and gas are being stripped away, eventually to be incorporated into our larger galaxy. This galactic cannibalism, a normal process in galaxy evolution, continues across the universe, regardless of observation. Dwarf galaxies throughout the local group continue their own evolution, some orbiting larger galaxies as satellites, others existing more independently. These smaller collections of starsum containing as few as 1,000 stars, compared to the Milky Way's 200 to 400 billion, follow diverse evolutionary paths. Some are dominated by ancient stars, having formed most of their stellar population early in cosmic history. Others continue to form new stars from remaining gas reserves. Some are being tidally disrupted by interactions with larger galaxies, their stars strewn across space in long streamers. All follow the laws of physics, whether their behaviors are catalogued and explained or left unobserved. Beyond our local group, the Virgo supercluster, a vast collection of galaxies spanning about 110 million light-years, continues its complex internal motions. Thousands of galaxies orbit within this enormous structure, some isolated, others in clusters or groups. The Virgo cluster, at its heart, containing about 1,500 galaxies, continues to grow by gravitationally attracting and absorbing smaller galaxies and groups. Our local group exists on the outskirts of this supercluster, gradually moving toward its center of mass while simultaneously being carried away by cosmic expansion. On the largest scales, galaxies are arranged not randomly, but in an enormous cosmic Weber network of filaments and walls surrounding vast cosmic voids. Matter follows these filaments, creating rivers of galaxies flowing through space, concentrating at the nodes where filaments intersect to form rich galaxy clusters. This cosmic architecture, invisible to the naked eye yet spanning billions of light-years, continues its evolution whether mapped by radio telescopes or left uncharted. The structure grows more pronounced over time as gravity draws matter into the filaments and empties the voids further. Galaxy cluster collections of hundreds or thousands of galaxies bound by gravity continue their internal dynamics. In clusters like Coma, Perseus, or Abell 1689, galaxies orbit a common center of mass at speeds of thousands of kilometers per second. The spaces between these galaxies are filled with extremely hot gas, millions of degrees Celsius, that emits X-rays as it falls into the cluster's gravitational well. This intracluster medium, containing more mass than the visible galaxies themselves, continues to heat and radiate energy without astronomers to detect its emissions. In the centers of most large galaxies, Supermassive black holes continue their quiet existence, occasionally activated when material falls within their gravitational grasp. When actively feeding, these black holes can power quasars and active galactic nucleism of the brightest sustained phenomena in the universe, visible across billions of light years. Jets of particles accelerated to near light speed erupt from the poles of some active galaxies, extending far beyond the visible boundaries of the host galaxies. These processes, among the most energetic in the cosmos, continue whether studied by astronomers or not. Throughout all galaxies, the life cycles of stars continue unabated. Stellar nurseries, vast clouds of gas and dust collapse under their own gravity to form new stars. Main sequence stars like our Sunday convert hydrogen to helium through nuclear fusion, releasing the energy that makes them shine. Massive stars burn through their fuel quickly and explode as supernovae, enriching the interstellar medium with heavy elements. White dwarfs, neutron stars, and black holes, the remnants of expired stars, populate every galaxy, their exotic physics continuing whether theorized or unexplained. Across the observable universe, an estimated 2 trillion galaxies continue their existence, each a collection of stars, gas, dust, and dark matter, organized by gravity into distinctive structures. Some are spiral galaxies like our Milky Way, with graceful arms winding outward from a central bulge. Others are elliptical, ranging from nearly spherical to highly elongated, containing mostly older stars and little ongoing star formation. Still others are irregular, showing no obvious symmetry or structure, often the result of galactic collisions or other disturbances. This diversity of forms persists whether classified by human taxonomy or left uncategorized. All galaxies drift through space carried by 3 primary motions. First, each galaxy has its peculiar velocity, its individual movement, relative to its neighbors, determined by local gravitational interactions. Second, galaxies participate in the streaming flows of the cosmic web, moving along filaments toward dense clusters. Third, and most significantly, all distant galaxies appear to recede from us due to cosmic expansion, not because they are actively moving away through space, but because space itself is expanding, carrying them along like raisins in rising bread dough. This cosmic expansion continues to accelerate, driven by the mysterious dark energy that comprises about 68% of the universe's total energy content. First discovered in our human timeline through observations of distant supernovae in the late 1990s, this acceleration means that galaxies beyond our local group will eventually move beyond our cosmic horizon, becoming unobservable even in principle. In this humanless universe, this fundamental aspect of cosmic fate continues its inexorable progress, without anyone to discover it, name it, or ponder its implications. Dark matter, comprising about 27% of the universe, compared to regular matter's mere 5%, continues to shape galactic structure and motion. This invisible substance, detected in our human timeline only through its gravitational effects, forms halos around galaxies, extending far beyond their visible components. It provides the additional gravitational pull needed to explain galactic rotation curves and the formation of large-scale structure. In this observer-free universe, dark matter continues its silent influence, whether detected or not, whether explained or remained a mystery. Galaxies collide throughout the cosmos, creating spectacular interacting systems. When 2 disk galaxies meet, their mutual gravity distorts their shapes, drawing out long tidal tails of stars and gas. These collisions stimulate waves of star formation as gas clouds are compressed by the gravitational disruption. Over hundreds of millions of years, the galaxies may complete a merger, combining into a single larger system, often transforming spiral galaxies into ellipticals in the process. These cosmic train wrecks, happening in slow motion by human standards, continue across the universe without anyone to witness their beauty or calculate their dynamics. Some galaxies develop active nuclei when material falls into their central supermassive black holes. The resulting quasars can outshine their entire host galaxies, powered by the incredible efficiency of matter-to-energy conversion in the black hole's accretion disk. Jets of particles accelerated to near light speed by intense magnetic fields can extend millions of light years into intergalactic space. These phenomena among the most energetic sustained processes in the universe continue, without radio astronomers to detect them or astrophysicists to model their complex physics. Ring galaxies form when one galaxy passes through the disk of another, creating a ripple effect like a stone dropped in water. The resulting rings of star formation expand outward from the collision point. Polar ring galaxies develop when material from a passing galaxy is captured into an orbit perpendicular to the main galactic disk. Lenticular galaxies combine features of both spirals and ellipticals, having disk structures but little ongoing star formation. These diverse outcomes of galactic evolution continue to develop across the cosmos, unclassified and uncatalogued. The most massive structures in the universe, great walls and filaments of galaxies stretching hundreds of millions of light years, continue their slow evolution. The Sloan Great Wall, extending more than 1.37 billion light years, and the Hercules Corona Borealis Great Wall, potentially spanning 10 billion light years, represent the largest known structures in our human-observed universe. In this observer-free scenario, these immense arrangements of matter continue to exist and evolve according to physical law, but without names, without measurements, without boundaries defined by survey limits or detection thresholds. All across the cosmos, galaxies emit light across the electromagnetic spectrum from radio waves to gamma rays that travels through intergalactic space. Some of this radiation is absorbed by the intergalactic medium, some is redshifted by cosmic expansion, and some continues potentially forever through the vacuum of space. Without receivers, without detectors, without eyes or minds to process this information, these signals represent pure electromagnetic propagation, rather than communication or data physics without information, transmission without reception. The cosmic microwave background, the afterglow of the Big Bang, itself continues to permeate all of space. This omnipresent radiation, cooled by cosmic expansion to just 2.7 degrees above absolute zero, still contains subtle patterns that preserve information about conditions in the very early universe, just 380,000 years after the beginning. These temperature variations of just 1 part in 100,000 continue to exist, whether mapped by space telescopes or left undetected, whether analyzed to reveal the geometry and composition of the cosmos, or left as meaningless fluctuations. The history of galaxy formation extends back to when the universe was just a few 100 million years old. The first proto-galaxy small, irregular collections of stars began to form from primordial gas clouds. Over cosmic time, these early systems merged and grew, gradually developing into the mature galaxies we observe today. This evolutionary history written in the light from distant galaxies that has traveled billions of years to reach Earth continues to exist as a reality, whether reconstructed by astronomers or left as uninterpreted electromagnetic radiation, crossing the void. Across all galaxies, stars continue to form from collapsing clouds of gas and dust, shine by nuclear fusion for millions or billions of years, and eventually expire according to their mass as white dwarfs, neutron stars, or black holes. Heavy elements continue to be synthesized in stellar cores and scattered through space by supernovae and stellar winds, gradually enriching the interstellar medium. New generations of stars and planets form from this enriched material, with increasing proportions of complex elements. This cosmic chemical evolution, the gradual transformation from a universe of primarily hydrogen and helium to one containing significant amounts of carbon, oxygen, iron, and other elements essential for planets, and life continues, whether recognized as significant or merely existing as chemistry. After trillions of years, star formation will gradually cease as galaxies exhaust their gas supplies or lose gas to intergalactic space. Existing stars will burn out one by one, leaving behind cooling remnants. Galaxies will gradually darken as their stellar populations expire, becoming collections of black dwarfs, neutron stars, and black holes drifting through darkness. Over unimaginably long timescales, even these remnants will decay, white dwarfs cooling to black dwarfs, neutron stars potentially collapsing to black holes, and black holes themselves eventually evaporating through Hawking radiation. This ultimate fate of galaxies, the transition from brilliant collections of stars to cold, dark graveyards, continues as an inevitable physical process, whether contemplated by intelligent minds or not. In this humanless universe, galaxies move through the dark, not metaphorically, but literally unobserved, unmeasured, unnamed. Their motion follows physical law rather than narrative. Their evolution represents process rather than progress. Their ultimate fate unfolds not as tragedy, but as physics. Without consciousness to wonder at their beauty, without science to explain their workings, without philosophy to ponder their significance, galaxies simply are collections of matter and energy, following the dictates of gravity, nuclear forces, and thermodynamics across cosmic time, significant only to themselves. In the vast emptiness between stars and galaxies, countless photons travel endlessly through space. These particles of light, born in the hearts of stars or the chaos of cosmic explosions, journey across the universe at 299,792 kilometers per second, the ultimate speed limit of our reality. In a universe without human observers, these messengers continue their silent voyages, carrying information that will never be decoded, telling stories that will never be heard. Every second, our Sunday alone produces an almost incomprehensible number of photons, roughly 10 to the power of 45, radiating outward in all directions. Most of these will never encounter any substantial matter, instead traveling outward into the cosmic void, perhaps for billions or trillions of years, until the expansion of space stretches their wavelengths beyond recognition. These solar photons, the ones that miss Earth, miss planets, miss asteroids and comets, become eternal wanderers, carrying the signature of our star's composition and conditions to no one. Across the observable universe, approximately 10 to the power of 23 star 100 rupees sextillion generate their own flood of photons. From red dwarfs barely warm enough to shine to blue hypergiants blazing at temperatures of 40,000 degrees Celsius, each star broadcasts its particular spectrum, its unique fingerprint of elements and conditions, through the electromagnetic radiation it emits. In our human world, astronomers would analyze these spectra to determine stellar composition, temperature, and motion. But in this observer-free universe, these detailed messages remain forever unread. The light from distant galaxies carries even richer information. Each galaxy's light represents the combined output of billions of stars, along with the glow of nebulae where new stars are forming, and the emissions from gas heated by supermassive black holes at galactic centers. The spectrum shows the redshift caused by cosmic expansion, encoding the galaxy's distance and age. The galaxy's shape and structure tell of its evolutionary history, whether it has remained isolated or experienced mergers with other galaxies. All this information travels faithfully across billions of light years, preserved in the properties of the photons, but with no one to receive and interpret it. Some of the most energetic events in the cosmos produce brilliant flashes of gamma rays, the highest energy form of electromagnetic radiation. Gamma ray bursts, likely caused by the collapse of massive stars or the merger of neutron stars, can briefly outshine entire galaxies. These bursts, lasting from milliseconds to minutes, send photons racing across the universe, carrying evidence of extreme physics at work. In our human timeline, orbiting detectors would register these events, triggering automated alerts to observatories worldwide. But in this observer-free scenario, these cosmic beacons flash undetected, their extreme energies noted by nothing. Not all photons travel indefinitely. Some encounter obstacles in their path. Interstellar dust absorbs and scatters light, particularly at shorter wavelengths, causing distant objects to appear redder than they actually are, a phenomenon astronomers call reddening. Some photons are absorbed by gas clouds, exciting electrons to higher energy states, which then emit new photons in different directions, and often at different wavelengths. These interactions between light and matter continue according to the laws of quantum physics, whether measured in laboratories or occurring unobserved in distant nebulae. Light also interacts with itself through interference patterns. When photons from the same source take slightly different paths, perhaps passing on either side of a galaxy whose gravity bends the fabric of space-time, they can interfere constructively or destructively when they reconverge. These cosmic interference patterns encode information about the mass distribution of the intervening object. In our world, this phenomenon allows astronomers to detect dark matter by its gravitational effect on light. In this observer-free universe, these interference patterns form and dissipate with perfect mathematical precision, their information content never extracted. Some photons have been traveling since the very early universe. The cosmic microwave background radiation consists of photons released when the universe was just 380,000 years old, when space finally cooled enough for electrons and protons to form hydrogen atoms, allowing light to travel freely for the first time. These ancient photons have been journeying for 13.8 billion years, stretched by cosmic expansion from their original high-energy state to microwave wavelengths. They carry the imprint of quantum fluctuations from the infant universe, preserving a baby picture of the cosmos that, in this scenario, will never be viewed. The light from the first generation of stars population 3 stars formed from pristine hydrogen and helium before the universe was enriched with heavier element travels through space, carrying evidence of these now extinct stellar pioneers. These stars, likely much more massive than today's stars, lived brief but brilliant lives before exploding and seeding the cosmos with the first carbon, oxygen, and other elements beyond hydrogen and helium. Their light, now greatly redshifted by billions of years of cosmic expansion, contains the spectral signatures of a younger, simpler universal historical record transmitted across time but never received. Within our solar system, sunlight reflected from planets and moons carries detailed information about their surfaces and atmospheres. The spectrum of this reflected light reveals which wavelengths have been absorbed, scattered, or reflected, allowing the composition of distant worlds to be determined. The polarization of the light can indicate whether it reflected from a solid surface or scattered through a cloudy atmosphere. These detailed messages from other worlds continue to radiate into space, carrying potential evidence of habitability or even life, but with no spectroscopes to analyze them or scientists to interpret the results. When light passes near a black hole, its path is bent by the extreme curvature of space-time, sometimes creating multiple images of the same background object, or forming Einstein rings-perfect circles of light surrounding the black hole. Some photons pass close enough to orbit the black hole one or more times before escaping, carrying information about the intense gravitational field they traversed. Others cross the event horizon and fall toward the singularity, their information potentially preserved in subtle quantum effects at the horizon's edge. These exotic light paths continue to form throughout the universe, perfect demonstrations of general relativity that go unwitnessed. Across cosmic history, the universe has gradually transitioned from opaque to transparent. In its earliest moments, the cosmos was filled with plasma too dense for light to travel freely. As the universe expanded and cooled, neutral atoms formed, allowing photons to travel without constant scattering. Later, these atoms were reionized by radiation from the first stars and quasars, creating the complex intergalactic medium we observe today. This cosmic evolution is written in the journey of photons across time, how far they typically travel before being absorbed or scattered, but in this scenario, this history remains unread. Some photons participate in quantum entanglement, Einstein's spooky action at a distance. When particles are created in certain processes, they can become entangled such that measuring the state of one instantly determines the state of the other, regardless of the distance between them. These quantum correlations persist across vast cosmic distances, maintaining their spooky connections whether observed or not. The universe continues to exhibit quantum behavior at its most fundamental level, regardless of whether consciousness ever evolves to be puzzled by it. Light also carries entropy disorder or randomness across the cosmos. When a star shines, it converts the low entropy, concentrated energy of nuclear fusion into high entropy radiation that spreads outward in all directions. This transformation from ordered to disordered energy drives the overall increase in cosmic entropy required by the second law of thermodynamics. This fundamental arrow of time continues to point forward. Whether consciously perceived or not, as radiation disperses ever more widely through expanding space. The interstellar medium is not completely transparent. Neutral hydrogen absorbs light at specific wavelengths, creating absorption lines in the spectra of distant objects. These absorption features allow the distribution of hydrogen between us and distant quasars to be mapped, revealing the cosmic web structure. Similarly, intergalactic dust scatters and absorbs light, particularly at shorter wavelengths. These interactions between light and matter continue across cosmic space, filtering and modifying the messages carried by photons in patterns that would be revealing if ever analyzed. Some photons are created in perfect quantum states through processes like stimulated emission, the mechanism behind lasers. Others are emitted in tangled quantum states through spontaneous processes. The quantum nature of light, its dual existence as both particle and wave, continues to manifest throughout the universe, regardless of whether complex brains evolve to be confused by this duality. Quantum field theory accurately describes these processes, whether humans discover its equations or not. Perhaps the greatest untold story carried by light is the potential existence of other life in the universe. If other civilizations have evolved on distant worlds, their presence might be detectable through technosignatures, artificial light, radio transmissions, atmospheric changes, or other modifications to their environment, visible across interstellar distances. These signals may well be traveling through space at this moment, carrying evidence that we are not alone. In our human timeline, projects like SETI search for such messages. In this humanless scenario, these potential greetings from the stars remain forever unreceived. The photons that fall on potentially habitable exoplanets carry the energy that could power photosynthesis or similar energy-capturing processes, potentially enabling life to evolve elsewhere, as it did on Earth. These light particles deliver both energy and information, regular cycles of their parent stars, the occasional energetic flares, the steady warming that maintains liquid water. This light helps create the conditions for life, and then illuminates whatever emerges, whether witnessed by other conscious beings or not. Over the longest timescales, the fate of all photons is determined by cosmic expansion. As space itself stretches, the wavelengths of photons traveling through it stretch as well, shifting toward the red end of the spectrum and losing energy in the process. Given enough time, trillions upon trillions of years 7, the most energetic gamma rays will be stretched to wavelengths larger than the observable universe, effectively fading from existence. This ultimate dissolution of light represents the heat death toward which our universe appears to be evolving, a state of maximum entropy, where no further work is possible. In this universe without observers, light travels not as information but as pure physics. The concept of seeing requires not just photons but a receiver, an eye, a detector, a consciousness to interpret the signals. Without these receivers, light exists in a liminal state, neither seen nor unseen, but existing in physical reality as electromagnetic waves propagating through space-time, according to Maxwell's equations. The universe remains lit, but not illuminated, bright, but not seen, full of messages, but without readers. This light that will never be seen represents perhaps the most profound aspect of a consciousness-free universe: the existence of signals without reception, of messages without readers, of beauty without appreciation. The cosmos broadcasts its nature continuously in the language of light, telling its story, photon by photon, across the vast distances between objects. The story remains true and complete whether read or not, whether translated into conscious understanding or left as raw physical process. The light continues its journey regardless, indifferent to observation, existing simply because it must, according to the universe's fundamental laws. In the vast reaches of space, stellar life cycles continue their relentless progression, a cosmic drama of birth, life, and death, playing out across billions of years. Without human eyes to witness them or human minds to comprehend them, stars still form from collapsing clouds of gas, still burn through their nuclear fuel, and still meet their varied ends according to their mass. These stellar stories, though unwatched, follow the immutable laws of physics that govern our universe. The story begins in the vast, cold molecular clouds that drift through interstellar space. These enormous structures, spanning dozens or hundreds of light-years, contain primarily hydrogen and helium gas, along with small amounts of cosmic, dust microscopic solid particles, of carbon, silicon, iron, and other elements created in previous generations of stars. These clouds are exceedingly tenuous by earthly standards, with typically just a few hundred to a few thousand molecules per cubic centimeter, compared to the roughly 10 to the power of 19 molecules in the same volume of air at Earth's surface. Yet despite this near-vacuum state, these clouds contain enough material, often millions of times the mass of our sun to birth entire clusters of stars. The process begins when a portion of such a cloud experiences a disturbance that compresses the gas. This initial push might come from the shock wave of a nearby supernova explosion, the gravitational influence of a passing star or cloud, the collision between two clouds, or the spiral density waves that move through galactic disks like ripples on a pond. Whatever the cause, once a region of gas becomes slightly denser than its surroundings, gravity begins to exert a stronger pull on that region, drawing in more gas and dust from the surroundings. As material falls inward toward this growing mass, the laws of physics dictate what happens next. Conservation of angular momentum, the same principle that makes a spinning ice skater turn faster when pulling in their arms, causes the collapsing cloud to rotate more rapidly as it contracts. Meanwhile, gravitational potential energy converts to thermal energy as gas particles fall inward, causing the temperature at the center of the collapsing cloud to rise. The cloud gradually flattens into a rotating disk with a hot, dense Centera protostar surrounded by a protoplanetary disk from which planets may eventually form. As material continues to accrete onto the growing protostar, its core temperature climbs higher and higher. Infrared radiation from this warming core tries to escape outward, but much is absorbed by the surrounding dust, heating it and causing it to glow in longer infrared wavelengths. If humans were present with their infrared telescopes, they would observe these objects as bright but visibly dark regions within the molecular clouds. Jets of material often erupt from the poles of the protostar during this phase, shooting outward perpendicular to the disk at hundreds of kilometers per second. These bipolar outflows help the developing star shed angular momentum that would otherwise prevent further collapse. The jets carve cavities in the surrounding cloud material, creating distinctive structures that would be classified and catalogued if astronomers were present to observe them. When the core temperature reaches about 10 million degrees Celsius, a momentous threshold is crossed. At this temperature, hydrogen nuclei move with enough energy to overcome their mutual electromagnetic repulsion and approach close enough for the strong nuclear force to bind them together. Hydrogen fusion begins, specifically the proton-proton chain reaction in smaller stars, or the CNO cycle, in more massive ones, converting hydrogen into helium and releasing enormous amounts of energy in the process. With this ignition, a true star is born. The onset of fusion creates an outward pressure that counterbalances the inward pull of gravity, establishing a state of hydrostatic equilibrium that will define the star's main sequence life. The remaining gas and dust in the protoplanetary disk may continue to form planets, asteroids, and comets, or it may be blown away by the intense radiation now pouring from the young star. The star's mass, determined by how much material it accumulated during formation, now becomes the primary factor that will dictate its entire life story and ultimate fate. Stars range from tiny red dwarfs with as little as 0.08 times the mass of our Sun and less, and they cannot sustain hydrogen fusiento blue hypergiants with more than 100 solar masses. This mass difference creates stunning diversity in stellar properties. The most numerous stars in the universe are the red dwarf small, cool stars, comprising perhaps 75% of all stars in the Milky Way, with masses between 0.08 and 0.4 times that of our Sun. These dim stars burn their hydrogen so slowly and efficiently that they can remain on the main sequence for trillions of years, far longer than the current age of the universe. In this human-free cosmos, these patient, enduring stars continue their glacially slow evolution, their faint red light illuminating countless planetary systems that will never know observation. Sunday-like stars, with masses from about 0.8 to 1.2 solar masses, make up perhaps 5% of stars in our galaxy. These yellow dwarfs, including our own Sunday, follow a more moderate path, with main sequence lifetimes of about 10 billion years. Our Sunday, currently about 4.6 billion years old, has enough hydrogen fuel in its core to continue stable fusion for another 5 billion years or so. Throughout the galaxy, countless solar analogues continue this middle-aged existence, providing stable illumination to their planetary systems, whether these are observed or not. More massive stars burn hotter, brighter, and faster. A star with 10 times the Sun's mass shines with roughly 10,000 times the luminosity, but remains on the main sequence for only about 20 million years, rather than billions. The most massive stars, the rare O-type blue giants exceeding 50 solar masses, might exhaust their core hydrogen in just a few million years, a mere cosmic eye blink. Yet in their brief lives, these stellar giants manufacture most of the heavier elements that will eventually enable rocky planets and complex chemistry. Across the galaxy, stars of all masses progress through their life cycles at rates determined by their mass. While a trillion-year-old red dwarf might still be in the earliest phase of its main sequence life, a massive blue giant born at the same time has long since exploded as a supernova, its material recycled into new generations of stars and planets. This asynchronous evolution creates a galaxy and, indeed, a universe where stellar birth, life, and death occur simultaneously across space. When a star exhausts the hydrogen in its core, having converted it to helium through billions of years of fusion, the first major transition of its life begins. With hydrogen fusion no longer generating outward pressure in the core, gravity temporarily gains the upper hand, causing the core to contract and heat up. Meanwhile, hydrogen fusion continues in a shell around the inactive helium core. For stars like our Sunday, this contraction raises the core temperature enough to expand the outer layers dramatically, turning the star into a red giant with hundreds of times its former volume. In this phase, the star's surface cools to around 3000 degrees Celsius, giving it a distinctly reddish hue, while its overall luminosity increases despite the lower surface temperature because of its vastly increased surface area. As the helium core continues to contract and heat, it eventually reaches about 100 million degrees Celsius, the temperature required for helium nuclei to fuse into carbon and oxygen. For stars less than about 2.2 solar masses, this helium ignition occurs suddenly in an event called the helium flash, a runaway fusion reaction that stabilizes within hours. For more massive stars, the transition to helium burning occurs more gradually. With helium fusion now providing outward pressure, the star's outer layers contract somewhat, and it enters a phase of core helium burning, while hydrogen continues to fuse in a surrounding shell. But helium fusion provides less energy per reaction than hydrogen fusion and occurs at a higher temperature, making it a less stable power source. This phase lasts only about 10%, as long as the star's main sequence lifetime. After exhausting its core helium, a star similar to our Sunday lacks the mass and corresponding gravitational pressure to ignite carbon fusion, which would require temperatures of around 600 million degrees Celsius. Instead, the core contracts once more, while fusion continues in shells of helium and hydrogen surrounding the now inactive carbon-oxygen core. The star becomes unstable, pulsating and shedding its outer layers in an expanding shell of gas, called a planetary nebular misnomer from early astronomers, who thought these round, often colorful structures resembled planets through their telescopes. These nebulae take on a stunning variety of shapospheres, hourglasses, butterflies, intricate interlocking rings determined by factors such as the star's rotation, magnetic fields, and whether it has a binary companion. These expelled outer layers, enriched with elements produced during the star's life, disperse into interstellar space, while the exposed core remains behind as a white dwarf, a curious object about the size of Earth, but containing roughly the mass of the Sunday. This incredible density means a teaspoonful of white dwarf material would weigh about 15 tons under Earth's gravity. The white dwarf shines not from fusion, but from residual thermal energy, gradually cooling over billions or trillions of years. Without fusion to maintain its temperature, the white dwarf will eventually fade to a black dwarf, a cold, dark ember of a once bright star. However, this process takes so long that in the current 13.8 billion year age of the universe, not even the oldest white dwarfs have had time to cool completely. For stars more massive than about 8 solar masses, the story continues beyond carbon. With sufficient mass and gravitational pressure, the carbon-oxygen core heats to temperatures that can ignite carbon fusion, producing neon and magnesium. In stars massive enough, subsequent stages can fuse these products to create silicon, sulfur, and eventually iron. Iron represents the end of profitable fusion. Fusing elements lighter than iron releases energy, but fusing iron and heavier elements requires an input of energy. When a massive star develops an iron core, fusion no longer provides the outward pressure needed to combat gravity. What happens next is one of the most spectacular events in the cosmos. With fusion no longer producing outward pressure, the core collapses catastrophically in less than a second. Protons and electrons in the core combine under the extreme pressure to form neutrons, releasing neutrinos, ghostly particles that immediately stream outward, carrying about 99% of the collapse energy. The outer layers of the star fall inward, then rebound off the newly formed neutron core, creating a shockwave that, boosted by a fraction of the escaping neutrinos, blasts the star apart in a Type II supernova explosion. For a brief period of days to weeks, a single supernova can outshine an entire galaxy of billions of stars. The explosion produces temperatures and pressures high enough to create elements heavier than iron through rapid neutron capture, the R process that creates roughly half of all elements heavier than iron, including gold, platinum, uranium, and many others. The expanding shell of debris, enriched with these newly formed elements, eventually mixes with interstellar gas, seeding it with the building blocks for future generations of stars and planets. The fate of the collapsed core depends on its mass. If the core has between about 1.4 and 3 solar masses, it remains as a neutron star, an object typically just 20 kilometers in diameter, but containing more mass than our Sun, composed almost entirely of neutrons packed together at nuclear densities. A sugar cube-sized piece of neutron star material would weigh about 1 billion tons on Earth. These extraordinary objects spin rapidly due to conservation of angular momentum during collapse, completing rotations in periods ranging from seconds to milliseconds. Many neutron stars emit beams of radiation from their magnetic poles, which sweep across space like cosmic lighthouses as the star rotates. If one of these beams happens to sweep across Earth, astronomers in our human timeline would detect it as a pulsar, a regular, precisely timed pulse of radio waves or other radiation. Neutron stars possess extreme magnetic fields, often trillions of times stronger than Earth's. Some, known as magnetars, have fields so intense they could erase a credit card from halfway to the moon. These fields can produce powerful bursts of gamma rays and X-rays. When the neutron star's crust experiences starquakes, sudden adjustments, similar to earthquakes, but involving shifts in a crust made of iron nuclei, electrons compress to quantum degeneracy. If the collapsed core exceeds about 3 solar masses, even neutron degeneracy pressure cannot withstand gravity's crush. The core continues to collapse until it forms a black Holian object, so dense that its gravitational field prevents even light from escaping. The boundary marking this point of no return is called the event horizon, which has a radius, the Schwarzschild radius, proportional to the black hole's mass, about 30 kilometers for a 10 solar mass black hole. Despite popular conceptions, black holes are not cosmic vacuum cleaners that suck in everything around them. At a distance, they exert the same gravitational pull as any other object of the same mass. Only by approaching the event horizon does one encounter the extreme gravitational effects that make black holes unique. Matter falling into a black hole forms an accretion disk, a rapidly rotating disk of gas and dust that heats to millions of degrees through friction, often emitting powerful X-rays before crossing the event horizon. According to quantum mechanics, black holes slowly evaporate over time through Hawking radiation process, where particle-antiparticle pairs form spontaneously near the event horizon, and occasionally one particle falls in while the other escapes. effectively carrying away mass energy from the black hole. For stellar mass black holes, however, this process is extraordinarily slow, requiring many times the current age of the universe to have any significant effect. Not all massive stars end their lives in isolation. Many are part of binary or multiple star systems. When one star in a close binary system expands into a giant, material can flow to its companion. If that companion is a white dwarf, gas accumulating on its surface can eventually trigger runaway fusion in a Type Ia supernova. Different mechanism, but comparably energetic to core collapse supernovae. These explosions completely destroy the white dwarf and play a crucial role in cosmic chemistry, being the primary source of iron in the universe. Binary neutron stars or black holes spiral gradually closer due to gravitational wave emission ripples in spacetime predicted by Einstein's general relativity. When they finally merge, they create some of the most energetic events in the cosmos: kilonova explosions, accompanied by short gamma-ray bursts and strong gravitational waves. These mergers forge heavy elements through the R process, complementing the nucleosynthesis that occurs in core collapse supernovae. Throughout the galaxy and beyond, stars continue to form in molecular clouds, enriched by previous stellar generations. Each new star contains slightly more heavy elements than stars formed in earlier cosmic epochs. The very first stars population, 3 stars in astronomical nomenclature, formed from pure hydrogen and helium with trace amounts of lithium produced in the Big Bang. Having no heavier elements to facilitate cooling during collapse, these first stars were likely extraordinarily massive, perhaps hundreds of times the Sun's mass, and correspondingly short-lived. The next generation population, 2 stars, formed from material lightly enriched by the first stellar explosions. These stars, found primarily in globular clusters and galactic halos, have low but non-zero metallicity. In astronomical terms, metals refers to all elements heavier than helium. Most recently formed are population 1 stars like our Sunday, born in spiral arms from gas significantly enriched with heavy elements from billions of years of stellar recycling. This gradual enrichment creates a universe that evolves chemically over time. The early cosmos contained essentially no elements beyond hydrogen and helium. Today, about 2% of the Milky Way's interstellar matter consists of heavier elements enough to form rocky planets, complex molecules, and potentially life. This cosmic chemical evolution continues in our observer-free universe, stars diligently manufacturing elements and distributing them through space in a grand cycle of stellar life and death. Throughout the Milky Way, an estimated 275 million stars form and die each day. In the observable universe, that number rises to about 100 billion new stars daily. Each follows the path determined by its mass, from the patient red dwarfs that will shine for trillions of years to the profligate blue giants that burn through their fuel in mere millions. Each enriches the cosmos in its own way, some through gentle planetary nebulae, others through violent supernovae, all contributing to the evolving chemistry of the universe. Some stars take more unusual evolutionary paths. Wolf-Rayet stars are massive stars that have lost their outer hydrogen layers, exposing hot cores and producing powerful stellar winds that create distinct emission lines in their spectra. Luminous blue variables like Eta Carinae undergo dramatic brightness changes and occasional giant eruptions, expelling shells of material while somehow avoiding complete destruction. Binary systems can follow numerous evolutionary tracks depending on their initial masses, separation, and how they exchange material, sometimes producing exotic objects like X-ray binaries, where material from a regular star accretes onto a neutron star or black hole companion. The stellar menagerie includes more exotic specimens as well. Some neutron stars spin hundreds of times per second, close to the theoretical limit, where they would break apart from centrifugal force. Some white dwarfs pulsate as they cool, experiencing regular expansions and contractions that would allow astronomers, if present, to probe their internal structure through astroseismology. Some stars experience rapid magnetic reconnection events analogous to solar flares, but millions of times more powerful. In globular clusters, ancient collections of hundreds of thousands of stars packed into spherical volumes just tens of light years across, stars experience a very different environment than their counterparts in the galactic disk. The extreme density of these clusters leads to frequent close encounters between stars, sometimes resulting in collisions or the formation of binaries through gravitational capture. Blue straggler stars in these clusters appear younger than they should be, likely the result of stellar mergers or mass transfer in binary systems that rejuvenated them. Across the electromagnetic spectrum, from radio waves to gamma rays, stars broadcast their nature through the specifics of their emission and absorption patterns. The absorption lines in stellar spectra reveal their chemical composition, which elements are present, and in what proportions. The broadening and shifting of these lines indicate the star's rotation rate and motion relative to Earth. The exact pattern of spectral features reveals the star's temperature, surface gravity, and evolutionary state. All this information continues to propagate through space in the form of light, whether or not any intelligence ever evolves to decode these stellar messages. In a universe without observers, stars still influence their surroundings in ways that would fascinate scientists if they existed. Massive stars emit powerful stellar winds and intense ultraviolet radiation that ionize nearby gas, creating bubbles of hot plasma surrounded by denser shells where new stars can form a process of self-propagating star formation. Supernovae create even larger bubbles and can trigger the collapse of nearby molecular clouds, initiating new episodes of star formation in a cosmic cycle of stellar feedback and induced star birth. The deaths of stars reshape their surroundings. Supernova remnants expand for thousands of years, eventually merging with the interstellar medium, but not before creating complex structures of hot gas, cosmic rays, and magnetic fields. Planetary nebulae from lower mass stars contribute processed material more gently but in greater numbers. As these stars are far more common, both processes seed the galaxy with the elements of which planet sand, potentially life are made. Our Sunday, typical among G-type main sequence stars, will continue fusing hydrogen in its core for another 5 billion years or so. When it eventually exhausts this central fuel, it will expand into a red giant, likely engulfing Mercury and Venus and rendering Earth uninhabitable, if not consuming it as well. After a phase of helium fusion lasting perhaps 100 million years, it will expel its outer layers as a planetary nebula and leave behind a white dwarf consisting primarily of carbon and oxygen. This solar evolution would have profound consequences for any remaining Earth-like planets in other systems undergoing similar transitions. As stars leave the main sequence, their habitable zones, the regions where liquid water can exist on planetary surfaces, move outward, potentially bringing previously frozen worlds into conditions suitable for liquid water and conceivably life. Later, as the stars become white dwarfs, any surviving planets would orbit dead stellar remnants, illuminated only by the gradually fading thermal glow of the cooling dwarf. The story of stars exemplifies the indifference of physical processes to observation. Stellar nucleosynthesis creates the elements of which planets, and potentially observers, are made, yet this process continues regardless of whether intelligence ever evolves to understand it. Stars shine whether or not eyes develop to see them. They manufacture complex elements, whether or not those elements eventually form living systems. The cosmic process that creates the conditions for potential observers operates with complete indifference to whether such observers ever actually emerge. In this observer-free universe, stellar evolution continues according to the immutable laws of physics. Stars are born from collapsing clouds, shine through nuclear fusion, and die in ways determined by their mass. Their remnants, white dwarfs, neutron stars, and black holes, continue their own evolutionary paths over timescales ranging from millions to trillions of years. The processes that would fascinate astronomers in our human time-linear nuclear burning, stellar pulsations, supernova explosions, neutron star mergers continue to occur, following the dictates of physical law, rather than performing for an audience. The rise and fall of stars represents perhaps the most fundamental creative process in the cosmos. Through stellar nucleosynthesis, the simple elements of the early universe, primarily hydrogen and helium, are transformed into the diverse periodic table required for complex chemistry. Carbon for organic molecules, oxygen for water, calcium for bones, iron for blood, all forged in stellar furnaces or explosive stellar deaths. The heavy elements necessary for rocky planets form only through stellar processes. meaning that every solid world in the universe owes its existence to previous generations of stars. This creative destruction continues across the cosmos, each star living according to its nature, following its predetermined evolutionary track, contributing in its own way to the changing composition of the universe. The cosmos gradually transforms from a simple state of primarily hydrogen and helium to a more complex state with a richer diversity of elements and compounds. This transformation occurs whether witnessed or not, whether appreciated or not, whether understood or note, a physical process rather than a performance, reality rather than spectacle. In this universe without witness, stars rise and fall according to physical law, their life cycles completing with perfect indifference to observation. They shine not to be seen, but because nuclear fusion inevitably produces light and heat. They die not as tragedy, but as physics. Their remains, whether gentle planetary nebulae or violent supernova remnants, disperse not as legacy but as material consequence. And yet, despite this lack of intention or meaning, the cycle creates the very elements that, in a different timeline, might eventually allow consciousness to evolve and contemplate the very processes that made its existence possible. Beyond the scale of stars and galaxies, the universe possesses structured intricate network of matter, stretched across the cosmos, like a spider's web. In this grand cosmic web, galaxies and galaxy clusters form the nodes, connected by filaments of dark matter and gas, with vast empty voids between them. But this immense pattern, the largest structure in existence, faces a slow demise as dark energy gradually pulls the universe apart. This cosmic web formed in the first billion years after the Big Bang. Tiny quantum fluctuations in the primordial universe, microscopic variations in density, were stretched to cosmic scales by inflation, the extraordinary expansion that occurred in the first fraction of a second of the universe's existence. These subtle density differences, visible today as temperature variations in the cosmic microwave background radiation, provided the seeds for all cosmic structure. Regions with slightly higher density had slightly stronger gravitational attraction, drawing in more matter from their surroundings and becoming progressively denser. Meanwhile, regions with slightly lower density lost material to their denser neighbors, becoming progressively emptier. This process of gravitational amplification transformed small initial differences into dramatic contrasts, the dense filaments and clusters, versus the nearly empty voids that characterize our universe today. Dark matter played the primary role in this cosmic architecture, making up about 27% of the universe's total energy content. This invisible substance interacts only through gravity, feeling no electromagnetic forces that might impede its collapse into structures. Dark matter began forming its web-like framework well before normal matter, which was still too hot and energetic to clump together. When the universe cooled sufficiently, normal matter, the protons, neutrons, and electrons that eventually formed stars and galaxies, fell into the gravitational wells already established by dark matter. This process created a universe organized like a cosmic sponge. Galaxies are not distributed randomly through space, but follow the dark matter scaffolding, forming filaments and walls surrounding vast, nearly empty voids. At the nodes where filaments intersect, particularly massive collections of galaxies form the galaxy clusters and superclusters that represent the largest gravitationally bound structures in the universe. The Virgo supercluster, our cosmic neighborhood spanning about 110 million light-years, contains the Virgo cluster at its heart and our own local group on its outskirts. The even larger Laniakea supercluster, spanning 500 million light-years, encompasses the Virgo supercluster along with several others. These enormous structures, containing thousands of galaxy groups and clusters, represent the culmination of 13.8 billion years of gravitational assembly. But the cosmic web is not static. It continues to evolve as gravity draws material along filaments toward the nodes. Computer simulations which would exist in our human timeline, but not in this observer-free scenario show. This evolution as a slow-motion flow, with galaxies streaming along the dark matter highways toward the cosmic intersections, gradually emptying the voids, and enriching the clusters. Meanwhile, a competing process has begun. About 5 billion years ago, the expansion of the universe began to accelerate, driven by the mysterious force we call dark energy. This acceleration, one of the most profound discoveries of modern cosmology in our human timeline, fundamentally alters the cosmic web's future. Rather than continuing to assemble under gravity's influence, the web has begun to pull apart, as dark energy overcomes gravitational attraction on the largest scales. Dark energy, making up about 68% of the universe's energy content, appears to be a property of space itself. Unlike matter, which becomes more dilute as the universe expands, the density of dark energy remains constant as space stretches. This means that as the universe grows larger, dark energy becomes increasingly dominant over matter and its gravitational pull. The cosmic web now faces a gradual unraveling. Structures that are already gravitationally bound individual galaxies, galaxy groups, and clusters will remain intact. But these islands of matter will grow increasingly isolated as the space between them expands at an accelerating rate. Gravity, with its strength diminishing with distance, cannot overcome the relentless stretching of space on the largest scales. Today, the observable universe extends about 46.5 billion light-years in radius from Earth. Limited by the distance light has had time to travel since the Big Bang, accounting for cosmic expansion. But as the expansion accelerates, an increasing portion of the cosmos recedes faster than the speed of light relative to our position. While nothing can move through space faster than light, space itself can expand at any rate, carrying galaxies with it like raisins in rising bread dough. This creates a cosmic horizon boundary, beyond which events can never be observed from Earth, even in principle. Galaxies currently near this horizon will eventually cross it, their light never reaching us, despite traveling at light speed through the expanding space. As time passes, more and more distant galaxies will cross this horizon, gradually shrinking the observable universe even as the total universe grows larger. In about 100 billion years, a mere eye blink in cosmic termsal galaxies, beyond our local group, will have crossed the cosmic horizon, becoming permanently unobservable from Earth. The light from these galaxies, though still traveling through space, will never reach us, because the intervening space expands faster than the light can traverse it. The night sky will gradually empty until only the gravitationally bound galaxies of our local group remain visible. The local group itself, primarily the Milky Way, Andromeda, and about 50 smaller satellite galaxies, will remain together, bound by gravity that easily overcomes dark energy's effect across these relatively small distances. Indeed, the Milky Way and Andromeda are currently approaching each other at about 110 kilometers per second, and will collide in about 4.5 billion years, eventually merging to form a single, larger elliptical galaxy, sometimes called Milkomeda or Andromeda Way. This merger will unfold over billions of years, the two spiral galaxies distorting as they approach, throwing out long tidal tails of stars as they pass through each other, and eventually settling into a single elliptical system. Despite the cosmic collision, individual stars almost never physically impact each other due to the vast emptiness of space. The stars within galaxies are separated by distances, millions of times their diameters. While our local group remains intact, the rest of the cosmic web gradually recedes beyond detection. The filaments and walls stretch thinner as space expands. The voids grow larger. Galaxy clusters beyond our local group move farther away, their light increasingly redshifted by the expanding space it traverses. Eventually, the cosmological redshift stretches even the highest energy gamma rays to wavelengths too long to detect, rendering distant objects not merely invisible, but undetectable by any means. This isolation of gravitationally bound structures represents a fundamental shift in cosmic evolution. For the first 9 billion years of cosmic history, gravity dominated on the largest scales, drawing matter into increasingly complex structures. For the past 5 billion years, dark energy has gradually taken control, and for all future cosmic history, its dominance will increase. the universe transitions from a matter-dominated phase, where structures grow more complex, to a dark energy-dominated phase, where structures become more isolated. Within these isolated islands of matter, gravitational processes continue. Galaxies within clusters gradually merge through dynamical friction, the tendency of massive objects moving through a field of lighter objects to lose energy and spiral inward. Over hundreds of billions of years, clusters will evolve from collections of distinct galaxies to single enormous elliptical galaxies surrounded by a diffuse stellar halo, the remains of cannibalized smaller galaxies. Gas between galaxies in these clusters continues to cool and fall toward the center, potentially fueling new episodes of star formation or feeding the supermassive black holes that reside in galactic centers. These black holes can grow to masses billions of times that of our Sun, their accretion disks shining brilliantly as gas spirals inward, heating through friction before crossing the event horizon. Meanwhile, the vast voids between filaments become increasingly empty as their remaining matter drains toward the web-like structures surrounding them. In the most underdense regions of the universe, matter density falls to less than 1/10 the cosmic average. With dark energy accelerating cosmic expansion, these voids grow ever larger and emptier, becoming true cosmic deserts. The intergalactic medium, the exceedingly tenuous gas filling the spaces between galaxies, also evolves. Initially composed primarily of hydrogen and helium ionized by radiation from early stars and quasars, this gas gradually cools as the universe expands. Some accumulates along filaments, potentially forming new galaxies where conditions permit. Some remains diffuse, forming an increasingly rarefied cosmic atmosphere that will eventually become undetectable as it disperses across expanding space. Within the filaments of the cosmic web, gas can reach densities and temperatures that allow it to emit X-rays detectable by instruments in our human timeline. This warm-hot intergalactic medium, WIM, may contain up to half the baryonic matter in the recent universe. As filaments stretch due to cosmic expansion, this gas cools and becomes more diffuse, its emissions fading from theoretical detection. The largest structures in the observable universe, great walls and supercluster complexes spanning billions of light years, ultimately have no gravitational cohesion. They exist as patterns in the distribution of matter, rather than as bound objects. These patterns, already being stretched by cosmic expansion, will gradually fade as their components drift beyond each other's cosmic horizons. The Sloan Great Wall, the Hercules Corona Borealis Great Wall, and other enormous structures will eventually cease to exist as coherent entities, their constituent parts isolated from one another by billions of light-years of ever-expanding space. The very largest voids regions, like the Boötis void, spanning 330 million light-years of nearly empty space, grow ever larger as their boundaries recede from each other. These cosmic cavities, already containing just 1/10 the expected number of galaxies for their volume, become increasingly perfect vacuums as cosmic expansion accelerates. All these processes, the stretching of filaments, the isolation of clusters, the enlargement of voids, would be imperceptible on human timescales. They unfold over billions and trillions of years, the slow-motion architecture of a universe gradually surrendering to dark energy's influence. In our human timeline, cosmologists would model these changes through computer simulations, extrapolating present conditions into the far future. In this observer-free scenario, the changes simply occur, following physical law without witness or interpretation. As filaments stretch beyond recognition and most galaxies disappear beyond the cosmic horizon, the universe transitions to its long-term fate-isolated islands of matter in an otherwise empty cosmos. These islands, initially galaxy clusters that have merged into single enormous galaxies, will themselves evolve over unimaginable timescales. Stars exhaust their fuel and expire. Stellar remnants gradually escape their galaxies through chance gravitational encounters. Planets either spiral into their parent stars or drift into interstellar space as their orbits are disturbed. Over timescales of 10 to the power of 19 to 10 to the power of 20 years, far longer than the current age of the universe even, these isolated islands gradually dissolve. Their constituent stars and stellar remnants escape into intergalactic space one by one through gravitational interactions. The galaxies themselves eventually evaporate, leaving their central supermassive black holes surrounded by increasingly diffuse clouds of stars, white dwarfs, neutron stars, and stellar mass black holes, all orbiting at ever-increasing distances. In the extreme far future, beyond 10 to the power of 40 years, even the supermassive black holes that once anchored galaxies begin to evaporate through Hawking radiation, the quantum process through which black holes gradually lose mass by emitting particles. The ultimate fate of the cosmic web is dissolution into fundamental particles, scattered across an ever-expanding void, too widely separated to interact or combine into more complex structures. The cosmic web, that grand structure that emerged from tiny quantum fluctuations in the infant universe, that provided the framework for galaxy formation, that channeled the flow of matter across billions of light years, ultimately unravels completely. What began as the largest and most intricate pattern in existence fades until no evidence remains that it ever existed at all. This unraveling, driven by dark energy's relentless expansion of space, represents perhaps the most profound phase change in cosmic history. The universe transitions from a state where gravity can create ever larger structures to one where gravity's influence is progressively limited to smaller regions. Complexity gives way to isolation. Pattern surrenders to emptiness. The universe that spent its first 9 billion years assembling increasingly intricate structures will spend its remaining future an infinite future if current understanding holds gradually erasing all evidence of those structures. In this observer-free universe, the cosmic web forms, evolves, and unravels according to physical law, its grand narrative playing out across billions and trillions of years, without witness or appreciation. The largest pattern ever to exist gradually fades from reality, its dissolution as mindless and mechanical as its formation a process, rather than a story, physics, rather than tragedy, existence without meaning or purpose beyond its own inherent reality. As time stretches into the far distant future, the universe continues its slow evolution toward higher entropy and lower energy. Without human observers to record the passing eras, to preserve knowledge, or to pass down stories, the cosmic history gradually becomes not merely forgotten but physically erased information itself, growing ever more diffuse in an expanding cosmos. In a universe with intelligence, knowledge accumulates. Discoveries build on previous findings. Records preserve what would otherwise be lost to time. Libraries, digital archives, monuments, and other repositories maintain information across generations. But in this humanless scenario, there are no historians, no scientists, no record keepers of any kind. Information exists only in its most fundamental physical form, the arrangement of matter and energy in space. The first information to fade will be the subtle patterns. The positions of stars gradually shift as they orbit the galactic center, erasing the constellations that would have been recognized by human cultures. Over millions of years, stellar proper motions, the tiny angular shifts in star positions, as viewed from Earth, completely rearranged the familiar patterns of the night sky. Alpha Centauri drifts away from Beta Centauri, destroying the pointer stars of the Southern Cross. The Big Dipper dissolves as its component stars move at different speeds in different directions. The celestial patterns that would have become cultural touchstones never form, or form and dissolve without recognition. Earth itself gradually loses its records of the past. Footprints that might have been preserved for millions of years are never made. Ancient cities never rise, and therefore never fall to become archaeological treasures. No fossils of human ancestors form in African sediments. No cave paintings preserve the artistic expressions of early Homo sapiens. No artifacts demonstrate the progression of technology. The geological record continues to accumulate, but without the distinctive Anthropocene layer that would have marked humanity's impact on the planet. The planet's natural processes continue to reshape its surface, erasing past conditions. Erosion wears down mountains grain by grain. Plate tectonics recycles the ocean floor back into the mantle approximately every 200 million years. Ice ages advance and retreat, scouring landscapes with glaciers. Asteroid impacts punctuate these gradual changes with sudden catastrophes, like the Chicxulub impact 66 million years ago that contributed to the extinction of non-avian dinosaurs. Each such event restarts ecological succession, creating new communities of plants and animals adapted to the changed conditions. Life continues to evolve, responding to changing environments through natural selection. Species appear and disappear, most leaving no fossils to record their existence. The fossil record, that incomplete library of life's history, accumulates new volumes that will never be read, preserving perhaps one species in 1,000 in conditions suitable for fossilization. Without paleontologists to excavate and interpret these remains, the history of life exists only as physical objects embedded in rock, their significance unmarked and their stories untold. On longer timescales, the sun's gradual brightening will dramatically alter Earth's surface, erasing even more evidence of what came before. Over the next billion years, the sun's luminosity will increase by about 10%, raising Earth's average temperature and accelerating its water cycle. Increased weathering of silicate rocks will draw down atmospheric carbon dioxide, eventually reducing it to levels too low to support photosynthesis. Plants that use C3 carbon fixation will disappear first, followed by the more efficient C4 plants. Without plant life to maintain oxygen levels, the atmosphere will gradually lose this reactive gas as it combines with surface materials. As the sunday continues to brighten, even the oceans will eventually evaporate. The water vapor subjected to photodissociation in the upper atmosphere, allowing hydrogen to escape to space while oxygen combines with surface rocks. The planet that was once blue with water becomes a dry, lifeless world with a carbon dioxide and nitrogen atmosphere somewhat like Venus, but without the extreme greenhouse effect. In this state, even more evidence of Earth's earlier conditions erases as the weathering processes that depend on liquid water cease. About 4-5 billion years from now, the sunday will exhaust the hydrogen in its core and begin to expand into a red giant. Its outer layers will extend possibly as far as Earth's current orbit, almost certainly engulfing Mercury and Venus. Whether Earth survives depends on two competing processes: the sun's mass loss through stellar winds, which causes planetary orbits to migrate outward, versus tidal interactions that cause orbits to decay. Most models suggest Earth will be engulfed, its entire physical structure vaporized and incorporated into the sun's extended atmosphere. If so, all remaining evidence of Earth's historic rock layers, its ice caps, its basin of accumulated sediments will be completely destroyed. The planet's entire 10 billion year history erased from physical reality. Even if Earth somehow survives the sun's red giant phase, perhaps left as a scorched, airless rock in a slightly wider orbit, the subsequent evolution of the sunday will subject it to further alteration. After its helium-burning phase, the sunday will expel its outer layers as a planetary nebula, leaving behind a white dwarf, a hot, dense stellar remnant about the size of Earth, but containing about 60% of the sun's original mass. This white dwarf will initially shine brilliantly, with surface temperatures exceeding 100,000 degrees Celsius, further scouring any planets that remain in the system. Throughout the galaxy, similar processes unfold as stars reach the ends of their lives. The interstellar medium is continuously enriched with heavy elements expelled from dying stars, then recycled into new star systems. This cosmic recycling gradually erases the distinction between material that came from different sources. Atoms that were once part of distinct stars mixed together in molecular clouds, their origins becoming untraceable. The universe maintains no record of which carbon atom came from which supernova, which oxygen atom was expelled from which red giant. On even longer timescales, the persistence of information faces more fundamental challenges. Protons, long thought to be stable elementary particles, may actually decay with a half-life of around 10 to the power of 36 years, according to some grand unified theories. If proton decay occurs, then all atomic nuclei will eventually disintegrate, converting ordinary matter into positrons, neutrinos, and radiation. Over such unimaginable timescales, far longer than the current age of the universe even, the most durable physical records would dissolve as their constituent atoms break down. Black holes, which form from collapsed stars and grow by accreting additional matter, represent information puzzles even in theoretical physics. The information about what fell into a black hole appears to be lost from our universe, contradicting quantum principles that information cannot be destroyed. Stephen Hawking proposed that black holes slowly evaporate through quantum effects near their event horizons, with larger black holes taking longer to disappear. A black hole with the mass of the Sun would take around 10 to the power of 67 years to evaporate, a timespan so vast it dwarfs the current age of the universe by a factor of 10 to the power of 57. Whether information truly escapes from evaporating black hole sand, in what form, remains one of the most profound questions in theoretical physics. The famous black hole information paradox. In this observer-free universe, the question is never posed, the paradox never formulated. Black holes simply form, accrete matter when available, and eventually evaporate according to physical law. Their information either preserved or lost according to the true nature of reality, untroubled by theoretical concerns that no physicist ever raises. As stars exhaust their fuel throughout the galaxy, the universe gradually darkens. Star formation continues for perhaps 1–100 trillion years as remaining gas clouds slowly collapse. But eventually, the raw materials for new stars are exhausted. Existing stars burn out one by one, leaving white dwarfs, neutron stars, and black holes. The white dwarfs, no longer powered by fusion, gradually cool over quadrillions of years from white to yellow to red to black, radiating away their thermal energy until they reach equilibrium with the cosmic background radiation. The universe enters the black hole era, lasting from about 10 to the power of 40 to 10 to the power of 100 years. During this almost incomprehensible timespan, ordinary matter has decayed through proton decay, if that process occurs. Black holes of various sizes dominate the cosmos, occasionally growing when they encounter matter or other black holes, but primarily losing mass through Hawking radiation. As they evaporate, they shine with increasing brightness, briefly becoming the brightest objects in the universe before disappearing completely. After the black hole era comes the dark Arathi final fate of the universe under current physical understanding. Starting around 10 to the power of 100 years from now, and continuing forever, the universe consists primarily of photons, neutrinos, electrons, and positrons, all constantly losing energy as space continues to expand. Occasionally, random quantum fluctuations might bring particles together to form positronium, a temporary atom consisting of an electron and positron orbiting each other. But these formations quickly annihilate. Complex structures no longer form. Information, in any meaningful sense, no longer exists. Long before these ultimate fates, information in more ordinary forms gradually degrades. Without maintenance, even the most durable human-made structure, had they existed in this scenario, would fall to ruin. Archives would disintegrate. Digital storage would corrupt. Languages would be forgotten with no new speakers to learn them. Knowledge itself would fade, as those who possessed it died, without passing it to new generations. The accumulated wisdom of a hypothetical civilization would disappear within a few centuries or millennia without active preservation. Even the position of Earth in its orbit represents a kind of information, the particular arrangement of the solar system at a given moment. Without astronomical record-keeping, the precise configuration of planets at any past moment becomes unrecoverable after a few orbital periods, as the inherent chaos of a multi-body gravitational system makes precise retrodiction impossible beyond certain timescales. The solar system maintains no record of where each planet was positioned a billion years ago. That information has been physically lost to the universe. In our human timeline, we attempt to preserve information across time horizons far exceeding individual human lifespans. We create time capsules, build monuments, establish archives designed to last centuries or millennia. We send spacecraft like Voyager and Pioneer beyond our solar system with golden records and plaques intended as messages to any intelligence that might someday find them. We transmit powerful radio signals to distant stars, knowing the messages will take decades or centuries to arrive. But in this humanless universe, no such efforts at information preservation exist. Each physical state simply gives way to the next according to natural law, with no consciousness attempting to maintain records of what came before. The past exists only insofar as its effects propagate into the present through causal chains. Once those causal influences fade, they all eventually do that aspect of the past ceases to have any physical representation in reality. It is not merely forgotten, it is physically erased. The universe maintains no central registry of its history. It simply exists in its current state, with certain arrangements of matter and energy that indirectly reflect prior conditions through the physical processes that produced them. In a universe without records, without memory, without consciousness, time functions differently than in our experienced reality. There is no history in the human sensino narrative connecting past events to present conditions through causal explanation. There is only the current state of the universe and the physical laws that transform one state into the next. The universe exists perpetually in the present moment, with each configuration of matter and energy giving way to the next, without reflection or remembrance. This recordless universe still contains patterns, the spiral arms of galaxies, the distribution of elements throughout space, the orbital resonances of planetary systems, but these patterns exist without recognition or interpretation. They are neither meaningful nor meaningless. They simply are. Information exists in its most fundamental physical form, the arrangement of matter in space, the distribution of energy across fields, but without systems evolved to extract and process this information, it remains mere pattern rather than knowledge. As entropy increases throughout the cosmos, an inevitable consequence of the second law of thermodynamics, these patterns gradually fade. Organized structures break down into more random distributions. Temperature gradients equalize. Concentrated energy disperses. The universe moves toward thermal equilibrium, a state of maximum entropy, where no further work is possible because no further energy can be extracted from differences in concentration or temperature. In this heat death of the universe, information in any meaningful sense ceases to exist as all particles reach the same energy state, with random quantum fluctuations providing the only deviations from perfect uniformity. A future without records is the universe's natural state, not an absence or a loss, but simply existence, without the artificial preservation of information that intelligent life would otherwise provide. The cosmos continues its evolution according to physical law, each moment giving way to the next, with nothing to mark what came before, except the physical consequences that briefly propagate forward through causal chains before themselves, fading into the background noise of an ever-expanding, ever-cooling universe. In the vast emptiness of a humanless universe, perhaps the most profound absence is not of observation itself, but of the potential for observation, the capacity for awareness that might have evolved, but never did. Consciousness represents a unique emergent property in our cosmos, a way for the universe to perceive and reflect upon itself. Yet in this alternative scenario, mind never arises from matter, and the possibility of subjective experience remains forever unrealized. On Earth as we know it, consciousness emerged through a remarkable series of evolutionary developments. Simple single-celled organisms gave way to more complex multicellular life. Specialized nervous systems developed to coordinate movement and response. Brains grew increasingly sophisticated, processing ever more complex information about environments. And somewhere along this continuum, subjective awareness appeared, an interior experience of the world, coupled with a sense of self experiencing it. In our humanless universe, this progression never reaches completion. Perhaps life itself never appears. The chemical processes that could lead to self-replicating molecules failing to establish themselves in Earth's primordial oceans. Or perhaps simple life forms evolve, but never develop the complex multicellularity necessary for neural systems. Or maybe multicellular organisms with simple nervous systems emerge, but never face the selective pressures that would favor increased cognitive capacity. At some point in this potential trajectory, the path to consciousness terminates, leaving a universe forever devoid of awareness. Without consciousness, the universe contains matter and energy interacting according to physical laws, but no experience of these interactions. Light travels across vast cosmic distances, but is never seen. Sound waves propagate through planetary atmospheres, but are never heard. Physical processes unfold with perfect fidelity to natural law, but are never felt, never understood, never appreciated. The distinction between subject and object, between the perceiver and the perceived, never emerges, leaving only objects without subjects, existence without experience. What does it mean for consciousness to never have been? Not merely that no humans evolved on Earth, but that nowhere in the vast cosmos did any form of awareness develop, no alien civilizations on distant worlds, no alternative cognitive architectures based on different biochemistry, no emergent consciousness in systems we might not recognize as life. The universe remains forever unconscious of itself, its existence unpaired with experience, its reality unwitnessed from within. This absence creates a curious ontological state. In philosophy, questions have long been raised about unobserved phenomena. A tree falls in a forest with no one to hear it. Does it make a sound? In our humanless universe, everything exists in this unobserved state. The physical vibrations that constitute sound occur, but without auditory systems to translate them into experienced sound. The electromagnetic radiation we call light propagates through space, but without visual systems to translate it into experienced sight. The universe exists physically, but not phenomenologically present in its material reality, but absent any internal experience. Potential itself becomes a curious concept in this context. The elements necessary for consciousness, carbon, hydrogen, oxygen, nitrogen, and other exist throughout the cosmos. The physical laws that would permit complex systems capable of information processing remain in effect. The energy sources that could power such systems shine across billions of galaxies. All the prerequisites for awareness exist, yet the potential remains unrealized, like an instrument never played or a language never spoken. Without consciousness, concepts themselves do not exist. There are no names for objects, no categories grouping similar phenomena, no abstractions distilled from concrete particulars. The hydrogen atom does not know it is hydrogen. The star does not know it is a star. The galaxy does not know it is a galaxy. These conceptual frameworks, the mental models that organize and make sense of reality, never develop in the absence of minds to create and maintain them. Values, too, remain non-existent. Without consciousness, nothing matters to anything. There is no suffering to be avoided, no pleasure to be sought, no beauty to be appreciated, no meaning to be created or discovered. The universe operates with perfect indifference, not because it chooses indifference over care, but because the very possibility of caring requires consciousness. Without awareness, value distinctions cannot emerge, leaving a universe that simply is, without being good or bad, beautiful or ugly, meaningful or meaningless. Purpose, similarly, cannot arise in a consciousness-free cosmos. Intentions require minds to form them. Goals require awareness of potential futures and preference for some over others. The movements of planets around stars, the fusion reactions within stellar cores, the gravitational attraction between galaxies all proceed according to physical law, without intent or aim. They are caused, but not purposed, determined, but not chosen, predictable, but not planned. In our human world, we often speak of potential as if it were a property of objects themselves. The potential energy of a boulder perched on a hillside, the potential of a seed to become a tree, the potential of a child to grow into an adult. But potential in this sense requires not just possibility, but a future state that could be realized. In a universe without consciousness, the potential for awareness exists only as a counterfactual what might have happened under different conditions, but did not and never will. This unrealized potential creates a peculiar absence. Not merely the absence of something that was and is no more, but the absence of something that could have been but never was. It is a gap not in reality, but in possibility, non-occurrence of one among countless possible cosmic histories. The universe continues without noticing this absence, without feeling any loss for what never came to be, its physical processes untroubled by the awareness that never emerged to contemplate them. Had consciousness evolved, it might have taken countless forms across the cosmos. On Earth alone, we see evidence of awareness in mammals, birds, some reptiles, and cephalopods like Octopus siche, representing an independent evolutionary pathway to some form of subjective experience. In our humanless universe, these diverse possibilities remain unrealized, like branches of a tree never grown, paths never walked, stories never told. The emergence of consciousness appears to require certain minimum conditions: sufficient energy flow to maintain complex organization, stable environments persisting long enough for evolutionary processes to unfold, physical substrates capable of information processing at the necessary scale and speed. These conditions exist on countless worlds throughout the universe, yet without the precise sequence of events that would lead to awareness, they remain merely potential foundations for a structure never built. Without consciousness, there is no experience of time as past, present, and future. Physical processes occur in sequence, earlier states influencing later ones according to causal laws, but the psychological experience of temporal passage, the feeling of now moving between what was and what will be never, emerges. Time exists only as a dimension of the physical universe, a parameter in equations describing change, not as the lived experience of moments flowing one into another. Similarly, space exists physically, but not phenomenologically. The three dimensions through which matter extends remain mathematical aspects of reality, rather than the experienced arena of existence. Without consciousness to create perspective, a point of view from which space unfolds in directions like up and down, left and right, forward and backward, space remains purely relational, defining how objects position relative to one another, without the subjective sense of being somewhere within that expanse. Information, in its technical sense, still exists. Physical systems still embody particular states that rule out alternative states, still undergo changes that reduce uncertainty about their configuration. But information, in the meaningful sense, data that informs a mind, that updates a cognitive model, that reduces uncertainty for an aware system, never materializes. The universe contains patterns, but no pattern recognition, signals but no recipients, messages but no understanding. Language, that remarkable system for encoding and transmitting thoughts between minds, never develops. No words name objects or actions. No grammar structures relationships between concepts. No dialogue exchanges perspectives. No poetry captures subjective experience. No scientific papers describe discoveries. No philosophical treatises explore ideas. The absence of language means not just the absence of communication, but the absence of the sophisticated conceptual frameworks that language both enables and expresses. Art, too, never appears. No paintings capture visual beauty. No music organizes sound into emotional experience. No literature explores the human condition. No dance expresses embodied feeling through movement. No architecture shapes space for both function and aesthetic appreciation. The creative expression that allows consciousness to represent and share its subjective experience remains an unrealized possibility, a capacity never developed, because the awareness it would express never emerged. Science, the systematic study of reality through observation, hypothesis, and experiment, cannot exist without conscious observers. The laws of physics still operate, but no one discovers their patterns or formulates their principles. The periodic table of elements remains implicitly present in the properties of matter, but is never explicitly recognized or organized. The biochemical processes that might have led to life are never catalogued or understood. The cosmos operates according to its principles, but without anyone to discern and describe those principles. Philosophy, with its fundamental questions about existence, knowledge, consciousness, and value, never arises to interrogate reality. Questions remain unasked. What exists? How do we know? What is mind? What matters? The universe contains no wondering, no curiosity, no reflection upon its own nature or meaning. The philosophical problems that arise at the intersection of subjective experience and objective reality never develop because the subjective side of that relationship never emerges. Mathematics, that abstract system that describes patterns and relationships with such precision, exists implicitly in the structure of reality, but is never explicitly formulated. The numerical relationships governing planetary orbits, atomic structures, and energy transformations remain embedded in physical processes, but are never extracted as concepts, never formalized in equations, never appreciated for their elegant universality. The universe follows mathematical principles without anyone to discover and describe them. Religion and spirituality, those systems of meaning-making that address ultimate questions through narrative, ritual, community, and transcendent experience, either develop. No creation myths explain cosmic origins. No moral codes guide behavior through divine authority. No rituals mark life transitions or celestial cycles. No meditation practices explore consciousness itself. No prayers express gratitude or petition for aid. The existential questions that drive spiritual seeking are never asked because no minds exist to ask them. The social dimension experience their relations between conscious beings, the emergent properties of groups, the dynamics of cooperation and conflict never materializes. No families form, no tribes coalesce, no nations rise, no cultures develop shared beliefs and practices, no economies exchange value, no political systems distribute power. The complex networks of relationship that characterize conscious social species remain unrealized, their potential confined to a possibility that never actualized. Even more fundamental, emotion never colors experience. No joy brightens existence. No sadness darkens it. No fear responds to threat. No love bonds beings to one another. No curiosity drives exploration. No awe responds to grandeur. No pride follows achievement. No shame follows transgression. The affective dimension of consciousness, perhaps its most immediately felt quality, never emerges to give existence its subjective texture and significance. The moral dimension of reality, the realm of right and wrong, good and bad, virtue and vice, remains forever potential rather than actual. Without consciousness capable of suffering or flourishing, nothing can be truly harmed or helped. Without awareness that can value some states over others, no condition can be better or worse than any other. Without the capacity for choice, no decisions can be praised or blamed. Ethics requires consciousness, and in its absence, the moral category itself fails to materialize. In such a universe, does beauty exist? Physical configurations that human consciousness might perceive as beautiful, the spiral arms of galaxies, the delicate structure of snowflakes, the patterns of waves on shore, still occur. The mathematical relationships that often underlie what we find beautiful, proportion, symmetry, complexity within order, remain present in physical structures. But without consciousness to perceive and appreciate these qualities, beauty exists at most as potential qualities that would be experienced as beautiful if consciousness were present to experience them. Perhaps the most profound implication of consciousness that never was lies in meaning itself. Meaning requires interpretation, a conscious process that relates one thing to another within a framework of understanding. Without consciousness, the universe contains correlations, causes, and effects, but not meaning in any recognizable sense. Nothing symbolizes anything else. Nothing refers beyond itself. Nothing represents or signifies. The web of relationships that constitutes meaning in our conscious experience remains unspun, leaving a universe of bare existence without the layer of significance that awareness provides. In our human experience, consciousness allows the universe to know itself, to evolve systems complex enough to perceive, model, and understand the very reality from which they emerged. Stars forge the elements that become planets, that nurture life, that develops awareness, that discovers how stars work a remarkable circular journey of matter becoming mind, that then comprehends matter. In a universe where consciousness never evolves, this circle remains open. The cosmos, forever unknowing of its own existence, its wonders unwitnessed, its story untold. This unrealized potential for consciousness represents not merely one missing feature among many, but perhaps the most significant absence possible, the non-emergence of the very quality through which significance itself arises. A universe without consciousness contains everything except awareness of what it contains. It exists without being experienced, persists without being perceived, unfolds without being understood. It is a reality complete in its physical dimension, but forever lacking the phenomenological dimension that, in our world, makes reality not merely existent, but known. What form does reality take when no consciousness perceives it? In a universe without observers, existence continues. According to physical law, matter still occupies space, energy still flows and transforms. Causality still connects events, but without the interpretive framework that perception provides. This is existence in its purest form. Reality without representation, being without witness. The world as it is, rather than as it appears to be. In our human experience, perception fundamentally shapes our understanding of reality. Our eyes detect only a narrow band of electromagnetic radiation, which our brains interpret as color. Our ears register pressure waves within a limited frequency range, which we experience as sound. Our sense of touch provides information about temperature, texture, and pressure through specialized receptors. This sensory information undergoes extensive processing and interpretation before reaching consciousness, creating our subjective experience of the world a representation, rather than a direct apprehension of reality itself. Without observers, this interpretive layer vanishes. The universe exists not as it appears to any consciousness, but simply as it is a vast collection of quantum fields and particles interacting according to mathematical relationships. The distinction between appearance and reality dissolves in the absence of observers for whom appearances could arise. What remains is a universe of pure being without seeming, of existence without appearance, of reality without perspective. Consider color, that vivid aspect of our visual experience that seems so fundamentally a property of objects. In physics, what we call color results from objects absorbing some wavelengths of light while reflecting or transmitting others. The wavelengths themselves possess no color. They are simply electromagnetic radiation of different frequencies. Color emerges only when these wavelengths interact with visual systems that translate them into distinctive experiences. In our humanless universe, wavelengths still exist. Objects still reflect and absorb them according to their physical properties. But color itself, blue, green, and all their variations never emerges, because no visual systems evolve to create this interpretive category. Similarly, sound exists only as mechanical vibrations propagating through media, like air or water. Without ears to detect these vibrations and brains to interpret them as auditory experiences, there is no sound in the experiential sense, no music, no thunder, no voices, no rustling leaves. The physical vibrations continue whether heard or not, but sound, as a phenomenological category, depends on conscious perception. In our observer-free scenario, pressure waves still propagate, but are never experienced as sound, just as light waves propagate, but are never experienced as color. Even more abstract categories disappear without consciousness. Beauty ceases to exist, not merely because no one appreciates beauty, but because beauty itself represents a relationship between objects and perceiving subjects. Without the subjective half of this relationship, beauty cannot arise, regardless of what physical configurations might have been experienced as beautiful had consciousness been present to experience them. The same applies to other aesthetic qualities: harmony, symmetry, elegance, which depend not merely on physical arrangement, but on how those arrangements affect perceiving subjects. Time has experienced the sense of duration, of past and future, of now moving forward differs from time as measured by physical processes. Without consciousness, temporal sequence, continuous events, still precede and follow other events in causal chains, but the subjective experience of temporal passage vanishes. There is no feeling of now moving from past to future, no anticipation of what comes next, no memory of what came before. Time exists only in its physical dimension, not in its psychological one. Space undergoes a similar transformation. In conscious experience, space unfolds around a perspective or point of view from which directions like up and down, left and right, forward and backward extend. Without consciousness, space exists only as relations between physical entities, defining their positions relative to one another. There is no privileged perspective, no center from which space unfolds, no distinction between here and there, except in terms of relative coordinates. Space becomes purely mathematical rather than experiential. Language, that sophisticated system for representing reality through symbols, depends entirely on consciousness. Without minds to create and interpret linguistic signs, the universe contains no names, no descriptions, no statements, no questions. Objects remain unnamed, their relationships unexpressed, their categories unformulated. The linguistic framework that allows consciousness not merely to experience reality, but to model it abstractly, to communicate about it, to reason with it, this framework never develops in an observer-free universe. Causality still connects events, with earlier states determining later ones according to physical law, but causality as an explanatory concept requires consciousness. Without minds seeking to understand why things happen, events simply occur in sequence without being explained. The universe maintains its causal structure without anyone recognizing this structure, modeling it, or using it to predict future states. Explanation, prediction, understanding these cognitive activities that build upon causal relationships remain unrealized in the absence of the consciousness that would perform them. Value distinctions good and bad, helpful and harmful, desirable and undesirable depend on consciousness capable of preference. Without awareness that can value some states over others, nothing can be better or worse than anything else. Stars form and explode. Planets develop and decay. Processes unfold and conclude all without being good or bad, all without mattering to anything. The universe operates with perfect indifference because there is nothing capable of caring about what occurs. Purpose and intention similarly depend on consciousness. Without minds to form goals and work toward them, events in the universe unfold according to physical law but without aim or intent. A river flows downstream not because it wants to reach the ocean, but because gravity pulls water toward lower elevations. A planet orbits its star not because it seeks to maintain its path, but because gravity bends its trajectory into an ellipse. Without consciousness to choose some outcomes over others, the universe contains causation without purpose, determination without intent. Information in its technical sense, the reduction of uncertainty about a system's state, continues to exist in an observer-free universe. Physical systems still occupy specific configurations that exclude alternative configurations. Changes in these systems still propagate from one region to another, potentially allowing one part of the universe to register what occurs in another part. But information in the meaningful sensor data that informs a mind, that updates a cognitive model, that reduces uncertainty for an aware system never materializes, because no minds exist to be informed. The laws of physics, those fundamental patterns governing how matter and energy interact, continue to operate whether discovered or not. Gravity still attracts masses toward one another in precise proportion to their mass, and inverse proportion to the square of the distance between them. Electromagnetism still governs how charged particles interact. The strong and weak nuclear forces still bind particles within atomic nuclei. Quantum mechanics still determines the behavior of the very small. These regularities persist independent of observation or formulation. At quantum scales, the relationship between observation and reality becomes particularly subtle. The quantum measurement problem, how definite classical outcomes emerge from quantum superpositions, prompted various interpretations, some giving consciousness a special role in collapsing the wave function. In our observer-free universe, quantum systems continue to evolve according to the Schrödinger equation. But whether definite classical outcomes emerge without conscious observation depends on which interpretation of quantum mechanics correctly describes reality, a question that remains unsettled in our physics. The many worlds interpretation suggests that all quantum possibilities actualize in separate branches of reality, with observation merely determining which branch the observer experiences. In our humanless universe, this branching would continue. But with no observers to experience different branches, the distinction between them becomes purely mathematical, with no phenomenological significance. Alternative interpretations like objective collapse theories propose that wave function collapse occurs through observer-independent physical processes, which would continue in an observer-free scenario. Mathematical relationships, those abstract patterns underlying physical reality, to govern the universe, whether formulated by mathematicians or not. The ratio of a circle's circumference to its diameter remains approximately 3.14159, whether anyone calculates this value or names it pi. The Fibonacci sequence still describes growth patterns in certain natural structures. The inverse square law still governs how radiation intensity decreases with distance from its source. These mathematical relationships remain embedded in physical reality, without being extracted as concepts or formalized in equations. The potential for life itself presents interesting questions in an observer-free universe. Given suitable conditions, energy sources, chemical building blocks, stable environments, life might still emerge as a self-organizing, self-replicating system that maintains its complexity against entropy through energy consumption and information processing. Simple organisms might still evolve through natural selection, developing adaptations to their environments without ever achieving the complexity necessary for consciousness. Life without awareness, a peculiar middle ground between non-living matter and conscious beings. The boundaries and categories that consciousness imposes on reality, the distinctions between objects, the classification of similar entities into types, the segmentation of continuous processes into discrete events, dissolve in the absence of minds to create and maintain them. The universe becomes a continuous field of interacting forces and particles, without the conceptual boundaries that pass it into manageable chunks for conscious understanding. Reality flows as an unbroken whole, rather than as a collection of separate objects and events, meaning itself that web of significance that connects one thing to another within frameworks of understanding vanishes in an observer-free universe. Without minds to interpret, to relate, to contextualize, nothing means anything else. Meaning requires consciousness as its ground and context. In its absence, the universe contains correlations, causes, effects, and patterns, but not meaning in any recognizable sense. Nothing symbolizes, represents, or signifies anything beyond itself. Beauty, often considered an objective quality of reality in some philosophical traditions, faces a complex status in this scenario. If beauty is defined as a relationship between object and perceiver as qualities that produce certain experiences in conscious observers, then it cannot exist without these observers. If beauty is defined as objective harmony, proportion, or unity in physical arrangements, independent of perception, then it might exist in some form, but without the experiential dimension that seems essential to our understanding of what beauty is. Similarly, mathematics, often regarded as discovered rather than invented, as descriptions of patterns inherent in reality, rather than human constructions, continues to structure the universe, whether formulated by mathematicians or not. The question becomes whether mathematical truths exist independently of minds to conceive them, or whether they require consciousness to emerge as distinct from the physical relationships they describe. This touches on ancient philosophical debates about the nature of mathematical objects and their relationship to physical reality. In our observer-free universe, complexity still develops through purely physical processes. Galaxies form intricate spiral structures. Weather systems generate complex patterns of atmospheric flow. Crystal structures exhibit elaborate geometric arrangements. But complexity, as a concept, as a way of categorizing and comparing different systems, never emerges, because no consciousness develops to create this analytical framework. The universe contains systems of varying complexity without anyone to measure or compare their complexity levels. Order and chaos similarly exist as physical realities, but not as interpretive categories. Regions of high and low entropy, of greater and lesser organization, persist throughout the cosmos, but without consciousness to contrast them, to perceive pattern against randomness. The distinction lacks the significance it holds in our conceptual frameworks. The universe simply exists in its varying states of organization and disorganization, without these states being categorized or evaluated. Scale: the vast range from subatomic particles to superclusters of galaxies continues to characterize cosmic structure. Objects and processes exist at widely varying sizes, from the Planck length, about 10 m³ meters, to the current observable universe, about 10 Walkrodrod meters. But scale as comparison, as relative size, as a way of contextualizing entities within larger or smaller frameworks, this depends on consciousness capable of conceptualizing different levels simultaneously. Without such consciousness, entities simply exist at their particular sizes, without being large or small, relative to conscious perception. Perhaps most profoundly, the question itself, what is the shape of existence without eyes, cannot arise in the very universe it contemplates. Questions require questioners. Curiosity requires curious minds, and reflection requires reflective consciousness. In our observer-free universe, physical reality continues according to its laws, but the layer of questioning, wondering, and seeking understanding that consciousness provides never emerges. The universe simply is, without anyone to ask what it is or how it came to be. This returns us to the ancient philosophical puzzle. If a tree falls in a forest and no one is there to hear it, does it make a sound? The physical vibrations occur whether detected or not, but sound as experienced requires a perceiver. In our humanless universe, this question expands to encompass all of reality. If a universe exists with no one to perceive it, what is the nature of that existence? It exists physically, but not phenomenologically, objectively, but not subjectively, in itself, but not for anyone. The shape of existence without eyes is reality in its most fundamental form, being without appearing, existence without experience, the universe as it is, rather than as it seems to be. Matter and energy continue their interactions according to physical law. Particles and fields maintain their behaviors according to their inherent properties. Causes produce effects through unbroken causal chainsaw, without the interpretive layer that consciousness provides, without the representation that perception creates, without the significance that meaning bestows. This is the universe in its self-reality without observers, existence without witness, being without knowing. It continues regardless, indifferent to its own unperceived state, complete in its physical dimension, while lacking the phenomenological dimension that, in our world, makes reality not merely existent but experienced. The cosmos remains, whether witnessed or not, its existence absolute, though its appearance seen, the absence of any consciousness to which it could appear remains forever potential, rather than actual. In a universe without human observers, without any observers at all, curious paradox emerges. Cosmic perspective, without perspective itself. The grand patterns of existence continue their unfolding, but without consciousness to adopt viewpoints, to take positions, to consider alternatives, to step back and see the whole. What happens to perspective when no one is there to hold one? Perspective, in its most literal sense, refers to a particular position from which something is viewed, a physical vantage point that determines what is visible and how it appears. In visual arts, perspective creates the illusion of depth on a flat surface by representing how objects appear smaller and closer together as they recede from the viewer. This fundamentally visual concept depends on a viewer, someone positioned at a particular point in space, perceiving objects around them. In our humanless universe, physical positions still exist. Points in space still relate to other points according to geometric principles. Objects still occupy particular locations relative to one another. But perspective as a phenomenon, as The appearance of reality from a specific viewpoint never materializes because no viewpoints exist. No eyes look out from anywhere. No visual systems process information about spatial relationships. No brains interpret these signals to create three-dimensional models of surrounding environments. Beyond the literal meaning, perspective also refers to a particular attitude toward or way of regarding something, the standpoint that influences interpretation. We speak of historical perspective, cultural perspective, personal perspective, each emphasizing how position, temporal, social, individual, shapes understanding. This metaphorical sense of perspective presupposes consciousness capable of adopting and maintaining positions on issues, of interpreting events through particular frameworks, of holding beliefs about what matters and why. In our observer-free universe, positions and orientations still exist. Physically, objects face certain directions. Events occur in particular sequences, but attitudinal perspective vanishes entirely. Nothing regards anything in any particular way. Nothing interprets events through frameworks of understanding. Nothing holds positions on issues or questions. The universe simply unfolds according to physical law, without being regarded from any standpoint, without being filtered through any interpretive lens. The cosmic perspective, that expanded viewpoint that encompasses the universe as a whole, that contextualizes Earth as one planet among billions, humanity as one species among millions, the present moment as a brief interval in cosmic history, requires consciousness able to transcend immediate surroundings through imagination and abstraction. It represents perhaps the ultimate achievement of conscious perspective taking, the farthest extension of our ability to adopt viewpoints beyond our direct experience. In our humanless universe, the cosmic patterns that this perspective would comprehend still exist. Galaxies still form and merge across billions of light years. Evolution still adapts organisms to their environments across billions of years. Matter still organizes into increasingly complex structures under suitable conditions. But the cosmic perspective itself, the viewpoint that would encompass these patterns, that would draw connections between them, that would extract meaning from their similarities and differences, never emerges, because no consciousness develops to adopt this perspective. Scale: the vast range from quantum fluctuations to cosmic superclusters still characterizes reality. The universe still extends across more than 60 orders of magnitude, from the Planck length to the observable horizon. But scale as comparison, as relative size, as contextualizing framework, this depends on consciousness capable of conceptualizing different levels simultaneously. Without such consciousness, objects and processes simply exist at their particular scales, without being large or small relative to anything capable of comparison. Time spans ranging from attoseconds to eons still structure cosmic processes. Events still unfold at widely varying rates, from quantum transitions occurring in 10⁻⁻⁻⁻⁻⁻⁻⁻ seconds to stellar evolution occurring over billions of years. But these diverse temporalities are never compared, contrasted, or contextualized. No consciousness marvels at how processes at different scales follow different characteristic timescales, at how what appears static at one temporal resolution reveals itself as dynamic at another. Complexity still develops through purely physical processes. Systems still evolve from simpler to more intricate arrangements under certain conditions. Information still processes through natural systems like DNA replication or neural signaling in simpler organisms. But complexity as a concept, as a way of categorizing and comparing different systems, never emerges, because no consciousness develops to create this analytical framework. The universe contains systems of varying complexity without anyone to measure or compare their complexity levels. The absence of perspective means the absence of wonder, that distinctive state of consciousness that combines curiosity, awe, and appreciation. Stars still shine, aurora still shimmer, ecosystems still function, but without being wondered at. The universe's grandeur continues without being admired. Its mysteries persist without being pondered. Its beauty exists without being appreciated. Wonder requires a wondering mind, and in our observer-free scenario, minds never develop to experience this fundamental response to existence. Without perspective, meaning itself transforms. In conscious experience, meaning emerges from relationships between things within interpretive frameworks, connections, contrasts, patterns, recognized and valued. Without consciousness to establish these frameworks, to recognize these patterns, to value these connections, the universe contains correlations, causes, effects, and regularities, but not meaning as we understand it. Nothing symbolizes anything else. Nothing refers beyond itself. Nothing signifies within larger contexts of understanding. The laws of physics, those fundamental patterns governing how matter and energy interact, still operate whether comprehended or not. Gravity still draws masses toward one another, according to precise mathematical relationships. Electromagnetism still determines how charged particles behave. Quantum mechanics still describes the probabilistic nature of subatomic events. But these regularities are never formalized into equations, never tested through experiments, never unified in overarching theories. They remain patterns in physical behavior, rather than knowledge about that behavior. Even more fundamentally, the very concept of laws of nature depends on perspective. Physical regularities exist regardless, but conceptualizing them as laws, as rules that reality follows, requires a law-giving or law-recognizing consciousness. The universe behaves consistently without anyone noticing this consistency, formulating it mathematically, or wondering about its origins. The distinction between descriptive laws, patterns we observe, and prescriptive laws, rules reality must follow, never arises, because no observers exist to make this distinction. The cosmic horizon, the boundary beyond which events cannot affect us due to the finite speed of light, and the expansion of space still, physically limits what regions can causally influence other regions. But the horizon as a concept, as a limit to observation, never develops, because observation itself never occurs. The universe's causal structure remains intact without being recognized, its limitations never contemplated, its implications for knowledge never considered. Counterfactual thoughts about what might have been under different conditions depend entirely on consciousness. Without minds to imagine alternative possibilities, to consider how reality might differ if initial conditions or physical constants were different, the universe contains only what actually occurs, not what could have occurred otherwise. The rich territory of possibility, so central to conscious thought, remains unexplored because no consciousness evolves to explore it. The anthropic principle, the observation that the universe's properties must be compatible with the conscious life that observes it, becomes peculiarly irrelevant in our observer-free scenario. The universe's fundamental constants and initial conditions might well remain the same, still falling within the narrow ranges that would permit complex chemistry, stable stars, and potentially life, but without observers to notice this compatibility, the apparent fine-tuning exists without being remarked upon. The question of why physical constants have values conducive to complexity never arises, because no consciousness develops to ask this question. Self-organization, the emergence of ordered patterns from initially disordered systems through purely local interactions, continues throughout the cosmos. Spiral galaxies still form from gravitational collapse of gas clouds. Weather systems still generate complex atmospheric flows. Crystal structures still arrange atoms in regular geometric patterns. But these processes are never recognized as examples of a general phenomenon, never compared across different scales and systems, never analyzed for their common principles. Each instance remains isolated, its similarities to other self-organizing systems unnoticed. Purpose and teleology, the sense that natural processes aim toward particular ends, vanish entirely in an observer-free universe. Without minds to project intention onto physical systems, to see goals where only causes exist, the universe operates with perfect mechanism, but without apparent purpose. Stars do not try to maintain fusion balance. Ecosystems do not aim for stability. Evolution does not seek increased complexity. These processes simply occur according to physical and chemical principles, their outcomes determined by initial conditions and natural laws, rather than by goals or intentions. The very idea of cosmic history, universe's development over time as a coherent narrative, depends on consciousness. Without minds to construct this narrative, to connect events into meaningful sequences, to identify crucial transitions and turning points, the universe simply changes state, according to physical law, one configuration following another, without constituting a story. Events occur in temporal sequence without forming a history in any meaningful sense. The past exists only insofar as its effects propagate into the present through causal chains. Without records, without memory, without the conscious reconstruction of prior states based on present evidence, the past has no existence beyond its causal influence on current conditions. The universe maintains no register of its history. It simply exists in its current state, with certain arrangements of matter and energy that indirectly reflect prior conditions through the physical processes that produce them. Similarly, the future exists only as potential states that will develop from the present according to physical law. Without anticipation, without prediction, without the conscious projection of current trends into subsequent conditions, the future has no existence beyond its eventual actualization. The universe unfolds without foresight, each moment giving way to the next without being anticipated or prepared for. In conscious experience, we naturally tend toward narrative structuring events into coherent stories, with beginnings, middles, and ends, with protagonists and challenges, with themes and meanings. In our observer-free universe, events merely occur in sequence without forming narratives. The Big Bang happens, matter forms, galaxies develop, stars burn and die, planets form and decay, without these processes constituting chapters in a cosmic story. Without storytellers, there are no stories, only sequences of physical states transforming according to natural law. The multiverse hypothesis, the proposal that our universe might be one among many, perhaps with different physical constants or initial conditions, becomes not merely untested, but unconceived in our observer-free scenario. Without consciousness to formulate such possibilities, to consider what might exist beyond the observable, to develop mathematical models of cosmic inflation or quantum branching, the universe contains only itself, its nature and boundaries unquestioned, because no questioning consciousness ever emerges. Information, in its technical sense, still exists. Physical systems still occupy particular states that rule out alternative states, still undergo changes that reduce uncertainty about their configuration. But information, in the meaningful sense data, that informs a mind, that updates a cognitive model, that reduces uncertainty for an aware system, never materializes because no minds exist to be informed. The universe contains patterns without pattern recognition, signals without reception, messages without understanding. The concept of emergence, how complex systems develop properties not predictable from their simpler components, never formulates without consciousness to notice these transitions, to be surprised by them, to seek explanations for them. Water remains liquid at room temperature without anyone recognizing that this property emerges from interactions between molecules that individually display no wetness. Consciousness itself, perhaps the most dramatic example of emergence in EVA, develops to recognize other emergent phenomena or to wonder about its own emergent nature. The universe's apparent fine-tuning, how fundamental constants, like the strength of gravity or the mass of the electron, fall within narrow ranges compatible with complexity, and potentially life continues whether noticed, not. The cosmological constant remains balanced with extraordinary precision against vacuum energy, allowing space to expand at a rate permitting galactic formation. The strong nuclear force remains precisely strong enough to bind protons and neutrons together without overcoming electromagnetic repulsion within larger nuclei. But these remarkable coincidences remain unremarked, their improbability uncalculated, their implications for cosmic uniqueness or multiplicity unconsidered. The concept of cosmic evolution, how the universe develops increasing complexity over time through purely physical processes, never formulates in the absence of observers. Matter still organizes into atoms, molecules, stars, planets, and potentially simple life forms, following entropy gradients and energy flows that permit local decreases in entropy, balanced by larger increases elsewhere. But this trajectory from simplicity toward complexity remains untraced, its patterns unrecognized, its implications for the relationship between physical law and emergent order unexplored. One might ask whether, in an observer-free universe, the philosophical question of whether unobserved objects exist would itself exist. The ancient puzzle: if a tree falls in a forest with no one to hear it, does it make a sound? Presupposes a questioner, a philosophical tradition, a language capable of formulating counterfactuals. In our humanless universe, not only would such questions never arise, but the very conditions for their possible consciousness, capable of wondering about unobserved reality, would never develop. The distinction between primary qualities, properties objects possess independent of observers, like mass and position, and secondary qualities, properties that arise in the interaction between objects and observers, like color and taste, dissolves in the absence of observers, for whom secondary qualities could emerge. The universe contains only what it contains: particles with their properties, fields with their strengths, systems with their dynamics, without these properties being categorized as observer-independent or observer-dependent, because no observers exist to make this distinction. Even the distinction between fact and value, between what is and what ought to be, between descriptive and normative statements, depends on consciousness capable of evaluation. Without minds to value some states over others, to establish normative frameworks, to distinguish between better and worse conditions, the universe contains only what occurs, not what should occur. Factual reality exists without normative assessment, behavior without ethics, outcomes without evaluation. The very concept of objectivity, knowledge, or judgment, uninfluenced by personal feelings or opinions, presupposes the possibility of subjectivity from which it distinguishes itself. In our observer-free universe, neither objectivity nor subjectivity exists. Only the bare reality that would be the reference of objective knowledge had consciousness evolved to formulate such knowledge. The universe exists neither objectively nor subjectively, but simply exists, unobserved, and hence uncategorized as either. Perhaps most profoundly, the cosmic perspective that allows consciousness to contextualize itself, to recognize its place within the universe from which it emerged, to understand its composition from the same fundamental particles that constitute stars and galaxies, to trace its evolutionary development from the same processes that govern all complex systems, never develops to complete this circle of understanding. The universe remains uncommented upon, uncontextualized, uncomprehended by any consciousness arising within it. The cosmic perspective without perspective represents perhaps the purest form of reality existence, without the interpretive layer that consciousness provides, without the representations that perception creates, without the frameworks that cognition constructs. The universe continues according to its nature, following the same physical laws that govern our observed reality, containing the same fundamental forces and particles, developing the same complex structures under suitable conditions, but without being perceived, without being known, without being wondered about. This is the universe in itself, rather than as it appears to consciousness, reality without interpretation, existence without experience, being without awareness. It continues regardless, indifferent to its own unperceived state, complete in its physical dimension, while lacking the phenomenological dimension that in our world makes reality not merely existent, but known. The cosmos remains, whether witnessed or not, its nature unchanged by observation, though its significance seen. The absence of any consciousness for whom it could be significant remains, forever potential rather than actual. As our journey through this observer-free universe draws to a close, we return to the fundamental question that has guided our exploration. What remains when no one is there to witness? The stars still shine. The galaxies still turn. The light still moves, tracing ancient paths across the dark. But without us, there are no names, no meanings, no memories. The universe we've traversed from Earth's silent landscapes to the cosmic web's gradual unraveling continues with perfect indifference to observation. Waterfalls still cascade down mountainsides, their waters catching sunlight in prismatic displays no eyes will ever appreciate. Supernovae still explode in spectacular releases of energy, briefly outshining entire galaxies before fading into expanding shells of gas and dust that no telescopes will ever detect. The cosmic microwave background radiation still permeates all of space, carrying information about the infant universe that no cosmologists will ever decode. This is perhaps the most profound realization of our journey. The universe does not perform for an audience. Its processes unfold not as spectacle, but as physics. Not as display, but as existence. Beauty occurs without appreciation. Complexity develops without understanding. Patterns form without recognition. The grand cosmic drama continues without witnesses, without interpretation, without applause. Yet there is something strangely comforting in this cosmic indifference. The universe does not need us to be beautifieds. Beauty persists as potential, ready to be experienced should consciousness ever evolve to experience it. The spiraling arms of galaxies maintain their elegant structure, whether admired or not. The delicate choreography of orbiting bodies continues its precise mathematical dance, whether calculated or not. The intricate ecosystems of living worlds still balance and adapt, whether studied or not. In this humanless cosmos, nothing is performed. Nothing is wasted. Nothing is missed. The universe simply is complete in itself, sufficient to itself, true to its nature, regardless of who might or might not be watching. It maintains its processes with perfect fidelity to physical law, neither exhibiting for observers nor slacking in their absence. Reality continues, unwitnessed, but undiminished. Perhaps what our journey really illuminates is not the universe without us, but the unique position of consciousness within the cosmos. In our actual timeline, awareness emerged from the same physical processes we've traced through their observer-free existence. Through billions of years of cosmic and biological evolution, matter organized itself into systems complex enough to perceive, to model, to understand the very reality from which they arose. Consciousness represents the universe turning its gaze upon its self-reality, evolved to recognize reality. This circular relationship, matter becoming aware of matter, the universe developing systems capable of understanding the universe, stands as perhaps the most remarkable achievement in cosmic history. Not because consciousness was inevitable or intended, but precisely because it was neither. In a cosmos governed by physical law rather than purpose, the emergence of awareness represents a profound, if accidental, development, the capacity for existence to be experienced, for reality to be known, for the universe to be wondered at. Sleep now, in a universe that does not need you but was still beautiful enough to hold you for a while. As your consciousness fades into slumber, remember that you carry something precious, the ability to witness, to know, to appreciate the cosmos that birthed you. For a brief moment in cosmic history, through your awareness, the universe sees itself. Through your understanding, matter comprehends matter. Through your wonder, existence marvels at existence. The stars will continue shining whether you watch them or not. The galaxies will continue their stately dance across expanding space, whether you map their movements or not. The fundamental forces will continue to bind and separate, attract and repel, create and destroy whether you formulate their equations or not. The universe does not need you to continue its existence, but without consciousness, that existence goes unmarked, unappreciated, unknown. As you drift towards sleep, consider this final paradox. The universe we've explored, the one without observers, exists only in your imagination, constructed through the very consciousness whose absence we've contemplated. Only awareness can conceive of its own non-existence. Only observers can imagine a world without observation. Only minds can wonder about reality without minds. Perhaps this is consciousness's most remarkable capability, not merely to experience what is, but to conceive what is not. Not merely to know the actual, but to imagine the possible. Not merely to observe reality, but to simulate alternatives. Through these abilities, Limited though they may be, consciousness transcends its immediate circumstances, reaching toward understanding that encompasses both what is and what might be. Sleep now, knowing that in your absence, the universe continues indifferent, yet magnificent, unchanged yet ever-changing, mindless yet ordered, purposeless yet perfect in its adherence to the laws of its nature. The cosmic drama unfolds, whether you watch or not, each scene giving way to the next according to physical necessity rather than narrative structure, each development following from what came before, without regard for audience reaction or dramatic effect. And yet, in sleep, as in wakefulness, you remain part of this cosmos, your matter formed in stellar cores, your energy derived from the same fundamental forces, your existence governed by the same physical laws that maintain galaxies and guide quantum particles. You are not separate from the universe you've contemplated, but integral to its particularly complex arrangement of the same fundamental ingredients that constitute all reality, organized in a pattern capable of perceiving patterns. Rest now in a universe that was never made for you, but made you nonetheless. Forged your elements in stellar furnaces, assembled your molecules under suitable conditions, developed your complexity through evolutionary processes, awakened your consciousness through neural organization. Without intent or purpose, without plan or foresight, the cosmos created the conditions from which awareness could emerge, a development neither necessary nor impossible, neither inevitable nor miraculous, but simply what occurred when physical laws operated on matter and energy over billions of years. The universe does not stop when no one watches, but it grows quieter, colder, more distant. Not in physical fact, the cosmos maintains its processes, regardless of observation, but in the realm of meaning, significance, appreciation. Without consciousness to witness it, the universe continues to exist, but ceases to matter, continues to function, but ceases to signify, continues its physical being, but loses its phenomenological dimension. Sleep now, surrendering awareness temporarily, knowing that billions of others maintain the vigil of consciousness, observing what you briefly cease to observe, knowing what you briefly cease to know, witnessing what you briefly cease to witness. And beyond human awareness, countless other forms of consciousness, from the sophisticated cognition of other primates and cetaceans, to the simpler awareness of insects, and perhaps even the proto-sentience of single-celled organisms, continue to experience the universe in their own ways, each capturing some aspect of reality within its particular form of awareness. The universe we've explored completely devoid of consciousness, remains hypothetical, a thought experiment rather than a known reality. As far as we can determine, once consciousness evolved on Earth, and perhaps elsewhere, it has maintained continuous presence, with new minds awakening as others fade. The completely observer-free cosmos may never have existed, and may never come to exist, a theoretical possibility rather than an experienced reality. Sleep now, in a universe that does not need you but was still beautiful enough to hold you for a while. And beautiful enough, perhaps, to create the conditions from which beauty could be perceived, from which existence could be known, from which reality could be wondered at, through the brief, improbable, remarkable phenomenon of conscious awareness.